believed to be safer. As we all know, natural products have played a pivotal role in human health and well-being for centuries. From traditional medicine to modern pharmaceuticals, the contributions of nature's bounty are immeasurable. Natural products offer extraordinary potential. They connect scientific innovation with cultural heritage, biodiversity conservation, and community well-being. Yet, unlocking this potential responsible requires interdisciplinary collaboration and global partnership. Ladies and gentlemen, this conference aims to bring together experts from various disciplines to share their insights, highlight the latest research and advancement in the field of natural products and their use in health. In these 2 days, we will explore discoveries in natural product chemistry, pharmacology, biotechnology, and integrative medicine. We will examine how natural compounds can help address chronic diseases such as cancer, cardiovascular diseases, diabetes, and neurodegenerative disorder. And equally important, we will discuss strategies to ensure that the use of natural resources support rather than threatens ecological sustainability and equitable development. I would like to express my sincere gratitude and high appreciation to our distinguished speakers who will deliver the insight and thoughts at this conference. Senkov from the City University of New York, United States, Professor Asif Muhammad Khan from Qatar, Professor Siti Efriza Asari from Malaysia, Professor Muhammad Irsan Saleh from Universitas Sriwijaya, Palembang, Professor Poppy Angelisa Hasibuan from Universitas Sumatera, and also Professor Samsudin from Universitas Pancasila, Jakarta. And the speakers also from our university is Dr. Insinyur Nonon Saribanon from Universitas Nasional, and my dear colleague, Dr. Vivitri Dewi Prasasti from Universitas Nasional, who is also the chair lady of this conference. I also would like to extend my heartfelt gratitude to the organizing committee, sponsors, and volunteers who have worked tirelessly to bring this event to fruition. Your dedication and hard work are truly appreciated. Ladies and gentlemen, while we are here enthusiastic and joyfully participating in this conference, some of our brothers and sisters in Aceh, North Sumatra, and West Sumatra are experiencing heartbreaking disaster of big flash floods. Let us pray together for their safe and health and hope this disaster will pass quickly and our brothers and sisters can return to their home safely. Ladies and gentlemen, once again, I would like to extend my deepest gratitude to all of you, to my dear colleague, Professor Irial Raskin, our wonderful speakers from United States, Qatar, Malaysia, and Indonesia, and to all oral presenters and poster presenters, and all participants, either on site or online, for your invaluable contribution. Thank you very much for dedicating your expertise to advancing global health and sustainable. I hope all the participants will have full advantage of this conference. The exchange of ideas is what makes conference like this so valuable. The other thing that makes a conference valuable is the opportunity for collaboration. I do hope that this conference will provide time, place, and atmosphere for our future collaboration. Thank you once again for being here. I wish you all a productive, inspiring, and memorable conference. Thank you very much. May God bless you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Dr. Ernawati Sinaga, MSAPT, for the wonderful welcoming speech. Ladies and gentlemen, now we would like to honorably invite to the stage Professor Ilya Raskin, PhD, Director of Center for Botanicals and Chronic Diseases, Rutgers, the State University of New Jersey, USA, to deliver his opening speech. To Professor Ilya Raskin, PhD, the floor is yours.
Again. Can you hear me now? Okay. All right, sorry. Again, wanted to say good morning to all my dear colleagues and friends and my partners in research and bioexploration, and I'm so delighted and so happy to be here. It's been 30 hours of flying and we're a little bit jet lagged, so I will at least read my introductory remarks and then show you some of our wonderful accomplishments, and because I'm so grateful to everybody who's here for those accomplishments. So it's really a joy and a great honor for me to be here with you in Jakarta once again. I believe it's the fourth or fifth time I'm here, and I'm delighted. Thank you very much, Ibu Erna, Ibu Nanon. I know Ibu Annie is somewhere here from Bryn, everybody else, the organizers, and of course our wonderful trainees. Every visit reminds me that Indonesia is not only one of the world's greatest biodiversity hotspots, but also a great hotspot of scientific talent, kindness, friendship, and hospitality. And it is really true, and I feel it from my heart. When we launched the Center for Botanicals and Chronic Diseases, none of us could imagine the scale of what would follow. Dozens of trainees completing training, master degrees, doctoral degrees, postdoctoral degrees, dozens of papers published, workshops spanning rainforests, botanical gardens and mountains, and most importantly, what I think is creating global community of scientists who now work together as easily as if Indonesia, Tajikistan, Ecuador, and the United States were the four neighborhoods located on the same streets, really being friends with each other and communicating very easily across the tremendous distances. BDCD shows that scientific excellence is not only built on institutions, and that's a very important lesson for me. It is built by the people and for the people. Our trainees have climbed cloud forests in Ecuador, navigated mountain peaks in Tajikistan, battled leeches in steamy jungles. We even fell from the collapsing bridges once in a mountain stream, and some of us remembers that, and all miraculously survived. And despite of all this, we managed to look extremely cheerful on the photos which were taken as a result of us being together. And now, when we enter the next chapter, what I call CBCD version 3.0, we are only expanding our training mission. And we're embracing new technologies, forging industrial and academic partnerships, and therefore we're so delighted to have our industrial partners here. So thank you all. Thank you all for being the heart of your program. It's all about people, about your generosity, and about your friendship. And I'm very grateful to be on this journey with you and look forward to many years of discovery and friendship. So thank you all, and I will have my first slide with that, please. Do I, yeah. All right, do I move the slides from here? Or, okay, this is just introduction. Let's move on, please. Yes. Okay, so I can see. So let me introduce the Center for Botanicals and chronic diseases in 3 countries now. It's Indonesia, Tajikistan, and Ecuador. Actually, this specific center was established in 2014, with Tajikistan being a member, and then Indonesia and Ecuador joining. Our mission is integrating the state-of-the-art science with the traditional knowledge about botanicals, which exists in both countries, and work together on these goals. Develop a sustainable mechanism for training graduate and postgraduate students, again working together. And it involves now 2 universities in the United States, 4 Indonesian universities, 2 Tajik institutions, and 1 Ecuadorian universities. And each country has a program director, and it's a pleasure to, again, remind you who they are. Dr. Patricia Rojas, who is a professor at University of San Francisco in Quito in Ecuador. Sedbek Satorov, who is a director of Center of Medicine in Tajikistan. Of course, our dear friend, Ernavati Sinaga, professor here, you know her. Vyacheslav Dushenkov, the co-director of the center from the United States. And all the participating universities. I'm so proud to show so many different emblems of all the universities which joined our program. Next slide, please. Well, what we're trying to achieve, and this is our main mission, is to really produce a scientific excellence through the individually led research projects which are assigned for every trainee. Training is supported by online courses, as you know, which we offer through Rutgers platform, in-person workshops, and actually we've had 5 wonderful workshops together. To me, this is the most rewarding experience, is working together in the jungles, next to the streams, collecting plants, studying plants, learning about their activity. And also international conferences, just like this one. Next one. So, as of today, and this is our report, as of today, we've graduated 56 trainees from 2014 in 3 different countries, 25 master degrees, 16 was completed in Indonesia, 9 in Ecuador, 20 doctorate degrees, 8 completed in Indonesia, 12 completed in Tajikistan, and postdoctoral fellows, it's really Tajikistan who has been with us for now 15 years, mainly postdoctoral training there in Tajikistan. We are very proud of their accomplishments of our trainees. Next one. And today, right after this lecture, we will be actually presenting the diplomas to the current trainees, Mohamed Usran, who is here, I believe, Anna Yulena Suprihatin, Desi Anya Olyena, Sukra Zaidan, and I apologize if I mispronounced your names, and Arya Chandra. And hopefully many more will come in the next phases of our training. Next one, please. Have a next slide. This is the scientific output of previous CBCD trainings. We've published 79 scientific articles in peer-reviewed journals. A lot of that is from Tajikistan just because they've been here longest. They've been part of the center. Oops, that's okay. And what is, well, presentations at the meetings, conferences, and so forth. Our trainees, and we're absolutely delighted, both from Indonesia and Tajikistan, now assume very important leadership roles in the research institutions in their country which deal with botanicals. Particularly in Tajikistan, where we've been 15 years, most of the actually centers and laboratories which deal with botanical medicines and natural products are led by our trainees. We're absolutely delighted about this accomplishment. Next one. So here is what is happening in the version 3 of our CBCD. And as some of you may know, we were just awarded another 5-year grant extension of the CD program from the National Institutes of Health in the United States, and we are very, very grateful for the funding they provided. So at this point, our center continues to expand. We're going to have 4 universities in Indonesia, again, dear Professor Ernawati Sinaga, thank you for bringing those wonderful universities and people to the program. We have one major university, probably the leading university, private university in Ecuador, Rutgers, and Maria de Hostos Community College, which is part of CUNY system in the United States. And we will have Tajik Center for Preventative Medicine and National Academy of Sciences in Tajikistan. And those two organizations together will be organizing another conference on natural products and health in Dushanbe, Tajikistan in May. And many of you will be invited to this conference. Next one, please. Okay, and here is the most exciting thing. This is what we are planning for the future of the center. This is what we are planning for the next 5 years. 26 scientists in Indonesia, 11 masters, 15 PhDs, 8 in Ecuador, 6 masters and 2 PhDs, 5 in Tajikistan, they'll all be postdoc, and Tajikistan will be actually ending participation in CBCD because this is what NIH wants. They now graduated to be self-sufficient into trainings in botanicals, but we'll still be officially 3 years with them, and of course we'll remain friends forever thereafter. Our goal this time, and that's what NIH wants us to align closer the scientific activities and projects in the US between graduate students and postdocs in the US working on natural products and human health, and in 3 participating countries. So truly creating this peer researcher system where people all across the world work together and publish together on the subjects which we decide they should be doing. Very importantly, and this is why Dr. Diana Cheng is here, we created, actually was successful in a very short period of time, created an industrial consortium associated with CBCD, because the goal of it is truly to enhance the translational component of research, the applied component, to make sure that discoveries which all of you are making find their way into helping people all over the world. And for that, we do need industrial partners who actually know how to produce those products we're discovering and market them for the benefit of mankind. And also working with IT department in Rutgers, and actually Dr. Dushenkov may talk about it, we're going to be trying to introduce the artificial intelligence assistant training, which is obviously everybody is new. It's an explosion which is occurring in basically every aspect of our lives, and hopefully can also help us to conduct our research more effectively and more efficiently. Next one. And what I want to acknowledge also is a major role which Global Institute of Bioexploration, or GIBEX, played in this program. GIBEX is really an umbrella organization which was founded in 2003 as a partnership between several universities in the United States, Rutgers, Illinois, North Carolina, Hostos Community College, and Louisiana State University, to truly create a global network working on novel ways of discovering and developing botanicals and natural product-based medicines. Next one, please. GIBEX has been extremely successful in the last quarter of the century, really, to provide novel, ethical, and sustainable approach to biodiversity conservation and natural product research, because it uses a new paradigm, as you some know, and this is what we are now doing for CBCD as well. We're not taking any materials from nature and bringing them to, let's say, US and Europe. We're actually enabling the discovery in situ, in your countries, by your people. All we're doing, we're helping and facilitating you to discover the value of your biodiversity and whatever new natural product-based medicines and consumer products can be there. And really working together to improve your R&D capacity. We're not taking anything out of country. We're just working together and learning from each other with everything occurring within the country. This is the GIBEX mode of operation, which has been very successful. Next one, please, next slide. Yeah, and using actually different funding from multiple institutions you may know, international, national, federal in the US. We actually have 28 members of GIBEX now, and we have conducted the GIBEX training in 17 different countries in red. And many of you are participating in this, and many of our students And this has really enabled these countries to work together. Hopefully some of them will get involved in the future cycles of CBCD. Next one. And this circles back, brings me back to this wonderful country, Indonesia, and why we're so particularly excited about you and truly the potential of your biodiversity, your natural product-based research for human health and human diseases, because you truly are a biodiversity hotspot in the world with so much traditional knowledge associated with the plant. I'm not going to read you this list because you probably know about it. Some ecosystems which you cannot find anywhere else in the world, from mangroves groves, so the peat jungles in Borneo, enormous amount of plant biodiversity, endemism, microalgae, which hopefully we'll actually learn much more about during the workshop, which we're going next one. This is a place for this to happen, and all those underutilized forest crops, which we're also so very interested about. Next one. And to me, because as some of you know, I'm interested in nature photography and always taking the opportunity to go and wander around with my camera. Those are just some pictures of totally endemic animals, which actually I was able to take during my several trips to Indonesian jungles, Indonesian forests. It is truly something to be proud of, but it's also something to be concerned about and try to protect, because obviously many of those animals are rapidly disappearing. And all of them are connected to this web of life and connected to these invaluable natural products which we can use from our jungles and our forests and our marine ecosystems, which you also have so much of. Next one. One of the important auxiliary type activity, which actually was initiated through CBCD and funded by APN, which is a Japanese foundation, was the beginning of the creation of this metabolomic depository, of the library of metabolome of endangered and endemic Indonesian plants. That was done in collaboration with BRIN. I think Professor Eni Subramanian, if somebody is here, she was key in this. This is based on the, again, Gibex technology, which was developed where you can actually impregnate the glass fiber discs with natural products extracted from all plants in multiple copies. Those discs are uniquely compatible with the microtiter plate assays, which also have been developed by Gibex. They work together. You can actually perform the assays in the field, and you can store the metabolomic collections without actually disturbing or distracting the plants. It usually uses a very small amount of plant material. You can store them on this fiberglass discs and then elute them whenever you want to study them, and it's all done in a format compatible with the assays. As you know, Antonia Kaz has been instrumental in conducting at least 2 workshops here, but also in different countries, on how to use this technology, Ramex technology, to preserve metabolome and actually a genome of endangered species for future generations. So we hope to renew this activity. We've already collected 500 samples with participation of UNAS and BRIN, and we hope to expand it in the next cycle and to get more funding for it. Next one. And again, on a personal level, which is very important, what this is all about is building scientific cooperations and finding friendships, understanding, and goodwill. Because what science does, it brings everybody together because we speak the same language, we share the same values. Sometimes politicians, cannot do that well. They keep us apart, but science can bring us together. And nothing is more humbling to me as coming here and learning from you and building these networks. Next one. And this is just pictures from the workshop. I'm just showing you some of those people you know. Again, we take a lot of pictures, you do too. And this is multiple workshops we've done, multiple meetings, hands-on training, and learning from each other. It's not just one-way street. It's absolutely, to me, a partnership, because I certainly have learned, and my colleagues have learned just as much from you about science, about your plants, about Jammu, whatever else, than we can ever teach you. And we are now, again, delighted to have our industrial partners join us, because I think this important component, translational research component, is so vital for what we're doing, okay? Because somebody got to bring it to people. Next one. Well, I just sort of want to thank people who worked with me on the most recent CBCD's activity in Indonesia. This is actually 3 of our graduate students whom you probably know, who contributed a lot to the CBCD's activities here. Sarah Skubal, actually now an educator, a professor at City University of New York. Isabel Armas, who is in Spain, and Antonia, who is now with us. And this is Dr. Dushenkov, who is, is also a key partner in this activity, and myself, paying tribute to Alfred Russel Wallace Memorial, of course, father of evolutionary theory, in Sulawesi when we visited the place where he worked. Next one. And that's it. I'm delighted again to show all those emblems of all the participating organizations. As you know, I can't even remember them, so that's why I have to put it on the slides and look at them sometimes. Thank you all very, very much. I wish you a very successful meeting.
Thank you, Professor Ilya Raskin, PhD. Please remain on the stage. And now the organizing committee will present a token of appreciation to Professor Ilya Raskin, PhD. We kindly invite Vice Director of Universitas Nasional and also Director of Center for Medicinal Plants Research, Universitas Nasional, Professor Dr. Ernawati Sinaga, MS.APT, to come forward to present the token. Give a big round of applause to Professor Ilya Raskin, PhD, Director of Center for Botanicals and Chronic Diseases, Rutgers, the State University of New Jersey, USA, as our keynote speaker today. On the stage, the next session is Trainees Awarding CBCD Program, a certificate of completion graduate from the MS program and PhD program supported and mentored by the International Research Training Center for Botanicals and Chronic Diseases, CBCD. Ladies and gentlemen, we will now proceed to the awarding of certificates for our outstanding trainers. And we kindly invite Professor Ilya Raskin, PhD, to present the certificate, and also we would like to invite Dr. Nonon Saribanon, MSc, as a mentor of the program, to come up to the stage. And we kindly invite Professor Dr. Ernawati Sinaga, MS.APT, to come forward to present the certificate for our trainees. And now, we are pleased to announce the award recipients. We request the awardees to come forward to receive their certificates. First, MS program, Muhammad Yusran, please come forward. trainees from PhD program. Ana Juliana. We kindly invite Sarah Zaidan. Chandra Gunawan Triwibowo Sudomo. For today, represented by Ibu Kristi. Muhammad Yusran, Ana Yuliana, Suprihatin, Desi Nadia Aulena, Sarah Zaidan, and also Arya Chandra. Please come forward for a group rotation. Invite all speakers, CBCD Indonesia. Please come forward for joining a group rotation. And next, we would like to invite CBCD Indonesia to come up for joining a group rotation with our trainees and speakers and also moderators. Please come forward for joining a group rotation. And now we would like to invite all the trainees from CBCD Indonesia to come forward for joining a group rotation with our speakers and invited speakers today. Please come forward. Alright, and now we would like to invite all participants today to come forward for joining a group photo session. Semuanya silakan maju ke depan untuk melakukan sesi foto bersama. Silakan semuanya boleh maju. Mahasiswa, para pembicara hari ini silakan semuanya boleh maju untuk melakukan sesi foto bersama. Stage, please turn around and face the camera. Silakan bisa semuanya berdiri di tempat supaya kelihatan. Thank you very much, everyone. That was a lovely moment. You may now return to your seats as we prepare for the next session of our conference. Ladies and gentlemen, before we continue the agenda, we would like to extend our deepest appreciation to our sponsors whose support has made this international conference possible. Our sincere gratitude goes to PT Antam Tbk, Analisa Resources, PT Indolab Utama, Luka Gel Antiseptik Wongel, and PT Plasma Unitech Global. Thank you very much for contributions. Distinguished speakers, ladies and gentlemen, before we continue to the next agenda, we kindly invite you to direct your attention to the screen. We have prepared a special short teaser to give you a deeper insight into the theme and spirit of today's International Conference on Natural Products and Chronic Diseases 2025. Please enjoy the teaser video of IC-NCD and CBCD. Thank you. Please give a big round of applause for IC-NCD and all of us here. Ladies and gentlemen, before we continue to the next agenda, we would like to invite all distinguished speakers to come forward for joining our group photo session to capture this memorable moment of the IC-NCD conference. Please come forward Professor Ilya Raskin, PhD, Professor Raymond R. Chandra Winata, PhD, MS MBA, Profesor Dr. Ernawati Sinaga, MS APT, Dr. Diana Klazar-Cheng, Profesor Dr. Muhammad Irsan Saleh, MBiomed, Profesor Dr. Poppy Angelisa, Dr. Insinyur Nonon Saribanon, MSI, Dr. Vivitri Dewi Prasasti, MSI. Thank you very much. You may return to your seats. Distinguished guests, ladies and gentlemen, now we move to the next agenda of today's conference, the keynote speaker presentation. It's our great honor to welcome our keynote speaker, Professor Raymond R. Chandra Winata, PhD, MS, MBA from Dexa Medica, Indonesia. The floor is yours.
Good morning, everyone. Good morning. I would like to thank Prof. Ernawati, obviously, for inviting me, and also Dr. Vivitri, whom I know since the last 20 years, I think, yeah. We've been spending time together before, but a lot of collaboration project. But thank you so much for attending this very important meeting on this, on the natural products. So Dr. Vivit has asked me to speak a bit about on the what we call hilirisasi, and how can we bring a product from the lab into the commercialization. So my experience has been in the pharmaceutical industry. Since 1996, I've been working in industry as a researcher as well as in business development. So I'm going to summarize of what I have done and what I have experienced in the last 20 to 30 years in bringing natural products into the in the setting of the healthcare setting, especially the formal setting for the prescription product by the physicians. Yeah. So hopefully it will give you some insight of how we think as an industrialist, how we bring a product into the hands of the doctors, the physicians, who will prescribe them to the patients. Yeah. Okay, may I have the slide, please? All right, so this will be the theme, bridging research to market. Essentially, we're talking about the integrative modern herbal products. Just to give you a clue, in Indonesia, there are a lot of jamu, a lot of OHT, what we call obat herbal terstandard, standardized herbal drugs, but not too many what we call phytopharmaca. There's only like, in brands, there are about 20 to 26, but in molecules, there are only 7 or 8 molecules of phytopharmaca. So that's why it's very surprising to us, Professor Ilya earlier, why are there like 3,000 medicinal plants in Indonesia, but there's only 22? That's even in the molecules, only 7. So this is what we need to do in Indonesia. Researcher, please take note, because we need to make more phytopharmacas. We need to make more of the OHT. because those are the ones that actually prescribed by the physicians. Yeah, jamu you can buy anywhere in the OTC market, but when the physicians want to prescribe drugs coming or medicine coming from natural product, then they need OHT or phytopharmaca. So what I'm going to do today is actually to give you an example of what we have done, what we've experienced to bring phytopharmaca into the market, into the hands of the physician. So slide. So first you have to do, first slide. Yeah, so essentially, because I'm in the pharmaceutical industry, but we're not a multinational company, we're a local company, but we bring a lot of phytopharmaca to the hands of the doctor. We even put into the formularium of the Department of Kesehatan, Ministry of Health in Indonesia. So essentially, we need to use, even though it's coming from traditional sources, like the materials that you gather from the biodiversity, but still, you need to use a lot of modern techniques, for example, genomics, proteomics, to bring all the potential, the possibilities, all the plant materials. So we do not only believe in what the data says in the old folklore, traditional books, but we have to, again, get the evidence based on scientific, whether it's DNA, whether it's protein, whatever have you, to bring about the new indication from the traditional plant, which widely prescribed or widely used as certain type of indication. Yeah. So I'm going to show you later on one of the examples. Next. Now, obviously, we need to do clinical trials. Yeah. This is the pivotal evidence that we need to put. If you have a new extract, if you have a new way of to do the biofractionation of the medical plant, then you need to put the evidence, which is the highest evidence, has to be in a clinical trial. Once you pass clinical trial, then you go to Badan POM to get the number registration, the marketing authorization. So it's very important that we do phase 1, phase 2, and mostly phase 3 trials. Yeah, please. Yeah, now, in order that we make a good product, what is a good product? Widely accepted, and when you produce it at a low cost, at what we call low COGS, cost of goods sold. And then thirdly, it has to be repeatable and standardized during the process. So from the raw material into the finished product, it has to be standardized. You cannot skip, for example, because the price of the raw material is going up, then I will change the raw material. You cannot do that. Once you have an OHT, that's why it's standardized, even to phytopharmaca, then you have only one source of supply. So if your herbs is actually coming from Sumatra, South Sumatra, then stick to South Sumatra. Do not change to find another sources, because the way it was planted or the way it was harvested or post-harvesting is different. Now, when you change any of the potential of the problem, the process, then you will have a different secondary metabolites. We don't want changes in secondary metabolites in quality and quantity. That's why it's called standardized, from the raw material into the finished product. So you have to make sure in the beginning, when you get the raw material, the quality people has to standardize also what kind of raw materials that we will have to secure the sourcing, even up to the production. So that's why when you look into the new product planning, don't think about the science first. What we need to think is what indication that the doctors will prescribe. Because science can come after the indication and the companies are patenting the result, yeah? And then we need to do also in the industry, building customer advocacy. Meaning, once we're in the middle of the trial, because we use the service of the physicians who does the trial in the local laboratory, in the local hospital, so we have to make sure that the potential prescriber also understand that we develop such a product for them later on to prescribe once the product got the registration number from Badan POM. Yeah? So these 3 things is obviously something that we need to do, and obviously it has to be done every time. Yeah, please. Okay, now, the key word now is how to translate traditional knowledge into modern application. And this is something that we need to put on because, yes, traditionally a plant has been used indication for hepatitis, for example, or for diabetes, or whatever have you. But in the end, during the process of the isolation of the active materials and also processing of the active materials into the finished product, turn out we have a new indication. I will give you an example how we can find a traditional knowledge for one medicinal plant. It turned out in the lab and in clinical trial, it turned out to be very different, even though it's coming from the natural product. So it's very important to do translational and look into the possibility of one medicinal plant can be used in different ways to do for the health conditions. Yeah. Next. Now, here's the difference. We know that in Indonesia, we have a jamu system. Actually, jamu is not traditional. It's traditional because it's been used by the people, folklore, for a long time. But now how can we translate this into Western? Because the doctors, they prescribe it not because of traditional way, which is, you can see here, is intuitive, synthetic, individual experience-based, clinical observation. But on the other hand, in the hand of the Western medicine, they look into analytical, standardized clinical evidence, pure chemical compounds, and also they ask what kind of receptor is your product coming from the natural product is bind to. Something like that. So we cannot use on the left-hand side, but we use on the right-hand side. On the left-hand side, it's been used by the TCM, by Campo, Ayurveda, and so on. But on the right-hand side, we're looking into phytopharmaceutical, or what we call botanical medicine, or what we call in Indonesia OHT and phytopharmaca. So there's a bridging. That's why what I've been saying, this is what we need to do, to bridge translationally what we know traditionally into a modern application of the same kind of the medical plan. Yeah. Next. So in order to do that, for example, if you have I just gave you an example, a Chinese formula, Liu Di Huang Wan, that's a Chinese TCM formula. It's been widely used thousands of years. How can it be translated into, for example, diabetes? Now we have to know, how does it in diabetes, in the pathological, when you look into molecular. So this thing, something that we need to, for example, yin deficiency and so on, it has to be translated into the Western medical field. For example, interleukin is going up. For example, yes, glucose is going up, but there's a GLUT4 reduction, something like that. So everything has to be translated into a modern setting. It has to be translated into molecular setting. So that's why when you find a new medical field in a new, a new fraction or a extraction from the of a medicinal plant, then you need to translate into a Western way, so that now the doctors know how it works. Yeah, so the doctor needs to know mechanism of action of your invention. That's why you have to translate it into medical field. Yeah. Next. Again, this is to show that you have to do clinical trial. Next. Okay, this is redundant, yeah? Go ahead. Next. Next. You're going forward, don't go backward. You go forward. One more. Yeah, okay, so this is an example of what we have done, yeah? So this is kayu manis, what we, as a cinnamon, yeah? In the world, I think there are 6 continents or whatever continents we have. There are more kayu manis species and genus in the whole world. For example, in Indonesia, there are at least 3 different species of kayu manis. In Irian, so it turned out that the one that is very good for medicinal purpose is the one that we found in South Sumatra. It's called cinnamon boomani. If you take cinnamon from Sri Lanka, it tastes good on top of the bread. Yeah, that's why when you go to the mall, you get, you smell cinnamon being sold on top of the bread. And that's the best thing, is actually because it's very aromatic. It's coming from Sri Lanka. The one that we found in South Sumatra is not very aromatic, but it has a very good medicinal property. Yeah. So this is a way to because many different species of kayu manis, many different cinnamon, but which one is the best for certain indications? So what we did actually with kayu manis, we'll fractionate the kayu manis from South Sumatra, and we found out at least there's 10 different fractions with 10 different indications. So 10 different pharmacological properties, two of which I will talk about today. It has become product here in Indonesia, in ASEAN. Soon we're going to Europe. Yeah? The above one is actually kayu manis, red acid, fraction number 2411. This is good for fat, acidic, for the stomach acid, GERD, yeah? Gastroesophageal reflux disorder. That's the one on top, yeah? While on the bottom, this is good for diabetes and PCOS. And a problem in women who cannot get pregnant because they get the multiple ovum generation, multiple ovum maturation. So they cannot get pregnant, and they cannot get menstruation for like at least 6 months. But given this like kayu manis, with the fraction 32 to 33, the patients get well. Then patients who cannot get pregnant suddenly become pregnant with this kayu manis, the different fraction, the one that we have found on top. The top one is actually being, it's been already going through clinical trials several times in FKUI also with Prof. Ari now, the decan, the dean of FKUI. Kayu manis on top of that is actually mimicking the proton pump inhibitor like omeprazole and pantoprazole. Both are coming from our backyard. Both are coming from the Gunung Kerinci in South Sumatra. Yeah. So next. That's why when we look into a different substance, yeah, next, it's okay. It doesn't have to be very sophisticated materials. Even with the very simple materials, the bark of the cinnamon, that can produces a good modern medicine, integrative medicine. So this is an example how we look, just as very simple. This is chemometric analysis on the left hand, on the left hand side. That's red acid 2411. Again, you're showing that there's a group, potentially probability different group of compounds between the two products coming from the same material, which is cinnamon burmani, but yet it has different indication. One is anti-diabetes on the right-hand side, PCOS, yeah, for the OBGYN. Now the doctors, OBGYN Indonesia has put it into the guidelines of managing PCOS. That's why they like it, because they don't have to use hormones anymore. They don't have to use birth control pills to manage this PCOS. Turn out to be simple product like kayu manis, cinnamon burmani can alleviate the problem of the PCOS in women who cannot get pregnant. On the left-hand side, this is for the refractory GERD. Patients who have been on omeprazole, pantoprazole, they've been on esomeprazole for a long time, and yet the acid still keep being produced. So that's why they keep coming back to the gastroenterologist asking for more and more medication. So on the left-hand side, you just get simple from the kayu manis that we get from here in South Sumatra. Yeah. Next. Okay, so when we make the bioactive fraction, then we have to test it in human being. So on this graph is actually showing how much pH is going up in the stomach of the patients. How do you measure that? In the laboratory, you can get easily with the fluid, and then you measure pH. But this is talking about the stomach pH. How do we do that? We cannot get the gastric juice all the time. So we ask the patients to swallow the probe, the pH probe, and then it lingers in the stomach for 24 hours. This is called pH metry. Yeah? So the patient's subject has to stay in the hospital for 24 hours, and every single period we take the gastric juice and measure the pH outside the stomach. So this is what we got. Look at the placebo is on the yellow, and the fraction of kayu manis, 250 milligram or 500 milligram, is on the purple or even blue. So it's going up, meaning it's actually very, very successful in increasing the pH. Once you have a pH 1 or 1.2, you feel very funny in the stomach. You don't feel comfortable. That's when you get GERD, because you got so many acid in the stomach. But when you increase the pH, you feel relief. You don't get the acid anymore. Yeah. Next. So this Professor Murdani at FKUI, he compared this DLBS 2411, which is the fraction of kayu manis on the bottom side, to the one that's a chemical product like omeprazole, which is it's a gold standard, prescribed PPI, a gold standard. It is actually available in our apothec, in OTC, everywhere, or even versus omeprazole. And what he found actually, hey, natural product is not inferior to chemical products. So it shows that if you design it properly, natural product even is not inferior. In many ways, it's similar or even superior to chemical products. So that's why now we're changing the physician's mind that now how you treat patients, not only chemical, drug, medicine, but think about natural medicine as an integrative way to measure, to heal the patient, to medicate the patient. Don't think about only drugs from chemical only. But we have in Indonesia so many biodiversity in which we can do the production, we can do the research, and we can make a lot of phytopharmaca for the country and also for EHT. Yeah? So again, if a good designed product from natural product can be brought into hilirisasi and will be used, and if we do the clinical trial, it will be used widely in all clinics in Indonesia, not even Indonesia, because potentially also be an export to certain countries in all over the world. Yeah, the one that's this one, Inlasin and Redacit's been in ASEAN countries, so doctors in Singapore is already prescribing them, in the Philippines, in Myanmar, and Cambodia, everywhere else is already prescribing Indonesian product now. Not only jamu, but as phytopharmaca. Yeah, so this has been prescribed, widely prescribed, is because it's working in the clinically. How do we know? Because we do clinical trials, GCP-based clinical trial. Yeah, so it is also incorporated in the guideline on how they treat patients. Clinical guidelines, very important. Yeah. So next, that's yeah. So what we did is actually we have about 7 protocol of clinical trials. It's only one of them because of the timing. In terms of the timing, I just show 1 or 2. Yeah? Again, this is GERD-Q score. This was done in Jakarta by the Koja Hospital, Dr. Susan Nugraha. But you can look at that. Group B is the on the black bar. There is the Redacit, which is the kayu manis fraction. On the left-hand side, this is head-to-head trial versus omeprazole. Now versus placebo, this is active control. Does the natural product beat the active control, which is chemical? And we did in the patients, it turned out to be very similar. In certain aspect, they're even better with the natural product from cinnamon compared to the chemical product. That shows again that a good design natural product, if you design it well, using the molecular biology, using the genomic, using the metabolism, whatever ways you do the research, but then you take it and standardize into a modern drug, then you can make a new modern drug based on the natural products. Yeah. Okay, next. So we've done quite a bit. That's only the 2 examples, Redacit and Inlasin, but many other ways. Now we're doing a lot of clinical trial to show that this natural product from Indonesia is not inferior to a chemical product. This is what we need to do more and more, not only data from laboratory. Yes, data from laboratory is just confirmatory, but what we do is actually we do the pivotal trial in the human being, in patients, in hospitals, by the physicians themselves to get data suggesting that yes, natural product is as good as chemical products. So when we if the country uses more natural products, drugs from nature, in the integrated setting, meaning we've been saying that, we've been hearing that Indonesia import raw materials for drugs from different countries, certain amount of $1 billion. If this program is actually successful, then the importation of raw material from outside, from China, from India, from anywhere else, will be reduced significantly. Because there are more natural products coming from the raw material from the woods, from the hutan, basically, instead of we import them. Yeah. Okay? Next. Okay, so Now, the government has already been very, very seriously tackling this issue. They put pharmacovigilance, means now when there is a side effect or adverse reaction happening in the patients, in a hospital, in a clinic, we need to report it to the government, Redcast, Kementerian Kesehatan, and even Badan POM. So this now, it's been implemented since 2021. It's good. It turned out that all the phytopharmaca, all the OHT in Indonesia doesn't cause harmful effects. It does not cause side effects. It does not cause adverse reaction. The number of reports in which given by to the government is already a lot and shows that natural products is actually very safe. As long as you design it properly, as long as you do toxicology study, and as long as you do safety studies in the phase 1 clinical trial. That's been proven over and over that yes, we can make good, safe, natural product. Because we hear anywhere else, for example, alpha-alpha can cause a lot of hepatotoxicity, and certain products can cause this cardiotonic problem and so on, yeah? That causes side effect and so on, palpitation, things like that. But in Indonesia, if you design it properly, you should not have a natural product which causes harm, which causes side effect, or even adverse reaction. And the good thing is the government takes really this very seriously, because we want to have a good, not only efficacious product, but also very safe. Yeah? So this is a good thing that we need, that we have here in Indonesia now since 2021, right during the COVID time. Yeah. Next. Okay, so I'm going to skip this because this is more very industry. When you put in your application for the marketing authorization, the government requires a lot of data, not from the lab, but how you produce the product, basically. How do you standardize the product? Is your process actually robust, method robust, and your interpretation also robust? So that's why even for the OHT phytopharmaca, sometimes the document is this big. So that's why you have to put in a lot of efforts to put all these documents in here. Next. And also very important, when you work with a pharmaceutical industry or jamu industry, they put a lot of this process design, improvement, process qualification, and so on, very, very tightly. Usually the quality control, quality assurance people from that industry, they have to understand, yeah, this usually is pharmacists, because pharmacists are required by the government to pay a lot of attention on the quality. All these things, it has to be in place. Otherwise, your standardized will be jeopardized. Otherwise, the quality of the product will not make, one batch is okay, but after 30 batches, you have to make sure the same standard quality has to be implemented by the industry. So that's why this is very important, starting from the process development until commercialization, until several years after commercialization, we still have the same kind of products that we had in the beginning when we apply into the health authority like Badan POM. Yeah. Okay, that's the idea of this slide. Yeah. Next. I think that's the last one. Yeah. Next. Okay, so, another thing, yeah. Have you heard 3 weeks ago, there's a news, I think it was done by people, our colleagues from BRAIN or any other, in which in Teluk Jakarta and certain sungai, certain rivers in Jakarta is already polluted with metformin. Metformin is diabetes drug. Long time ago, during the COVID time, we found Teluk Jakarta is also high incidence of paracetamol. It's probably not because of the people just dumping paracetamol, no, because they keep taking paracetamol, and then it's metabolized via the urine, it goes through the sewage system, and it ends up at the sea. It ends up at Teluk Jakarta. It ends up in our river. Now it's happening the same thing with metformin. So how do we circumvent that? We have to use green pharmacy, meaning natural product, because natural product is much more, because it's natural, it's alami, it's much more friendlier to the environment than a chemical synthesis would. So this is why we need to put our government a pressure to make sure that more natural products are being used in the formularium, in the FASKES, which is Fasilitas Kesehatan Modern, wherever the physicians prescribe. So this natural product is coming from the green pharmacy, especially the natural ingredients, is very, very satisfying for us who work in this field. Because once you think about product, and once you launch a product does not pollute the environment, that's the biggest thing that you can get is satisfaction. Your result, your research that you put a lot of time, a lot of efforts, a lot of soul from yourself coming to that, it actually comes to fruition. And very, very happy, it does not pollute the environment. So this is the idea of green pharmacy, in which we have to instill in the mind of the bureaucrats, in the minds of the Kementerian Kesehatan, yeah, so that there are more and more with the biodiversity-based pharmaceuticals will be used in the in the health setting. Yeah. Okay. Next. Okay. Thank you so much for your attention. Hopefully, it will shed up some lights. How can we produce such a natural product with chemical evidence? How can we bring it to the government also to make them include into the formularium? Because otherwise, our importation of chemical product will be high. But if your product is actually being used by the physicians all over Indonesia, that give you a lot of satisfaction as a researcher. So thank you very much, and selamat pagi. Ya. Thank you.
Thank you, Professor Raymond R. Chandrawinata, PhD, MS, MBA from Dexa Medica Indonesia. Dimohon untuk tetap di depan, Bapak. And now the organizing committee will present a token of appreciation to Professor Raymond R. Chandrawinata, PhD, MS, MBA from Dexa Medica Indonesia as our keynote speaker. May we kindly invite Dr. Vivitri Dewi Prasasti, MSE, to come forward and present the token. Dr. Diana Klasser Cheng from International Flavors and Fragrance, United States, Ronald Flavors and Fragrance, United States, Professor Dr. Muhammad Irsan Saleh, M. Biomed from Universitas Sriwijaya, Indonesia. This session will be guided by our moderator, who will lead the discussion and facilitate the question and answer segment with our participants. And now please welcome our moderator, Dr. Konita Basalama, who will take us through the discussion. To Dr. Konita, the stage is yours.
Vice Rector of Research, Corporation and Community Engagement, our Mahaguru, Professor Erna Sinaga. Good morning, Ibu. The conference chair, Dr. Vivitri Dwi Prasasti. Good morning, Ibu. Keynote speaker, Professor Raymond Chandrawinata. Good morning, Bapak. To all invited speakers, panelists, and organizers, Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Allow me to express my gratitude. I'm very delighted for being appointed as moderator of this first session. And I'm very proud to be part of this third conference, international conference on natural product and chronic disease that carry the theme Natural Product for Quality of Life, Advancing Global Health and Sustainability. These two significant words, health and sustainability, seem now as a very privilege that we all been lacking for quite some time. As today we stand in the intersection of the tradition and innovation, natural products and remedies has been the cornerstones of medicine and wellness. Together, we explore the multifaceted role that natural products play, from medicinal application to the environmental and ethical implication. As an anthropologist, I see medicine not only to cure, but also to carry the value that intergeneration, as we say, the local wisdom, that how we teach our children how to nurture their nature, their bodies, and their environment. So for this first session this morning, we would like to invite two prominent speakers, Dr. Diana Klasser Cheng, the Research Director research and development, taste botanical, and botanical at International Flavor and Fragrance New Jersey, US, United States, and Professor Dr. Muhammad Irsan Saleh, M. Biomed from Universitas Sriwijaya. Dr. Diana will speak for about 20 minutes. And please join me to welcome Dr. Diana Kaiser-Cheng to the stage.
All right, good morning, everybody. Thank you so much for inviting me to this international conference. And I'd like to introduce to you international flavors and fragrances. So we all talk about chronic diseases in terms of drug development, but another area of natural products chemistry that can be applied is in the flavor industry, and that's where I've been working at for the past 11 years. My background was in doing research with the Center for Botanicals Research through Ilya Raskin's lab in the past, for the past maybe 20 years or so already. And so I'm really happy to be invited here to share how we can apply this natural products research chemistry in industry. So please, if you can start up my slide deck. So today I'll be talking to you about natural products in the flavor industry, crafting healthier foods and beverages experiences globally. So first, a brief introduction into IFF. Next slide, please. Our purpose is to make joy through science, creativity, and heart. So the science is all the natural products chemistry that we do, at least in this aspect. Creativity is how we use it and apply it to make fun, interesting flavors that are also better for us. And heart is our investment into people and the sustainability aspect. So IFF is a global leader in flavors, fragrances, food ingredients, and health and biosciences, though I'll be focusing on the flavors aspect. So we deliver groundbreaking sustainable innovations that elevate everyday products that we all interact with and taste. And these help to advance wellness, delighting our senses, and enhancing our human experience every day when we have snacks and fun. So in making, next slide please, in making joy through science, creativity, and heart, we also want to make sure we do more good. So when we work on these developing new products, we want to make sure they're sustainable, they're ethically made. But also, it's a pretty large industry that maybe we don't often think about, since academic funding often focuses on health, but industry also pays attention to health and is a valued area for research as well. Next slide, please. And in doing more good, we're not only looking at sustainable, but trying to use less water, less resources, and able to achieve these goals, and make sure that we're working with them in an equitable and way that is conducive to everybody's. Things that make our clothes cleaner. So my company also develops enzymes for detergents and laundry care. We also have probiotics and prebiotics for making our tummies feel a little bit better, making food healthier and tastier, the world smell better with fine fragrances, but also consumer fragrances. Animal health and nutrition is another area that we work in, and also doing all this again in a sustainable way as we can. Next slide, please. So we touch a lot of products. So just a few tidbits here. About 1 out of 2 nutrition bars in the world contain IFF ingredients. 1 out of 5 hard seltzer in North America contain IFF flavors. Let's see. 1 out of 2 ice cream bars contain IFF ingredients. So you probably have interacted with ingredients that is part of our company and you don't even know it. I certainly didn't know it before I joined IFF, and even now I don't know where everything goes. It's such a large supply chain, but a very established way of utilizing natural products chemistry. Next slide, please. So So we're able to tap into all these different areas because we actually have 4 business units. Taste, which is the food and beverage area that I work in. Food ingredients, which is more focusing on protein and hydrocolloids and cellulose ingredients. Health and biosciences, where we might have some of the nutraceuticals and probiotics and prebiotics, as well as our enzyme technology. And then scent, which is all of our aromatic ingredients that I mentioned. So in the next slide, I'll talk to you a little bit more about flavor and taste as what our business unit is called. So flavor, we've all known about it for quite a while, right? The Silk Road, exploration in the Far East of spices and herbs. And then we move about 65 years later to the industrialization era, where we first started doing more chemical synthesis of these ingredients and understanding a little bit more about what they are. So benzaldehyde, vanillin, ionones, these are all really well-known chemicals that we use in flavors and fragrances. And then moving further on, we gain more into analytical chemistry and development and understanding more about what is in our products and what are in our extracts. So now in our present time period, we're taking more of a technological approach, focusing not only on the flavor chemicals and compounds, but how we deliver them, how we control their release, stability, and interaction with food as we put them all together and mix up beverages want, is what the consumers want. And if consumers also want to improve the health, or at least eat ingredients that have lower sugar, salt, and fat, as a flavor company, we try to mitigate that by developing flavor ingredients that help us reduce the intake of sugar, salt, and fat. So in the next slide, we want to try to balance this taste experience, because if you just reduce sugar and salt, you probably won't like what your product tastes like anymore. So we have to find other ways to balance this and elevate this experience. And one way we do this is called taste modulation. So many flavor houses will have this area of research. So taste modulation, if you want to go to the next slide, is the modification of basic tastes. So our basic tastes are sweet, salty, bitter, umami, and sour. And we want to balance the tastes of these because this is kind of incorporated into every ingredient that every food or beverage that we take. And the balance can really throw it off. It will be unpleasant if you had too much salt, so we don't want to have too much salt, but you also want to have enough to make sure it tastes right. So with taste modulation technology, as we call it, and our technology is a molecule or an extract, and it's not unlike, the research area is not unlike how you would develop a pharmaceutical drug, although the difference is our bioassay is just by tasting everything, and that is how we determine whether or not it is useful. So in the next slide, you'll see that the perception of flavor is multimodal. Next slide, please. Next slide, please. Okay. The perception of flavor is multimodal. That means you eat something, yes, you taste it on your tongue, and those are your non-volatiles. But also, you're creating aromatics that you're smelling maybe from the food or beverage, and then orthonasal. And then when you chew it, you also get aromatics that come from the back, or retronasal. And then all these signals go into central nervous system, and then you get a perception that is different. Now, there's a lot of complexity in what all goes on, but just to note that there are different aspects of taste and smell. So in the next slide, in understanding the palate, we break it up into 3 different areas. Taste, our basic taste, as I mentioned, olfaction or aroma, everything that is volatile and that interacts in different mechanism, as well as the trigeminal sensation. So those are perceptions of tingling, heating, warming, but those are all different in different areas and different types of compounds and chemosensory perceptions. Next slide, please. So for taste, we consider the human taste cells and the receptors. So for the 5 basic tastes, we have 5 basic receptors of sweet, sour, bitter, umami, and salty. And then there's some putative receptors in the area of kumi, and also maybe fat and maybe chemosenses. But for the basic taste, we just look at those. And like all your bioassays in which you're looking at specific biochemical signals, we can use taste receptors in the same way. So in the next slide, you'll see that, yes, there are taste receptors, but one sweet molecule is not the same. And where it binds can have an effect on how it's perceived. So you know that sugar has a binding area in the venous flytrap domain, but also there are other high-intensity sweeteners and other sweeteners that bind in different locations, and that gives a very different perception. But sometimes this perception is not what people want, depending on the type of sweetener. So if you think about stevia, let's go to the next slide. The stevia, the temporal profile is very different. It's very long, it's very lingering, and it's very high impact. So you only need 1,000 ppm, parts per million, to taste it, and also it's intensely sweet already compared to its 6% sugar. So you can use it at very low levels, but the perception, you will know, are quite varied in terms of what molecules and how many molecules that they will bind and interact with. So the bitter taste receptor system is quite complex. And then, next slide, please. For taste interactions, keep on clicking into, for taste interactions, you will see that they are all interconnected. And so there's quite a balance between all of these basic tastes, all interacting at once, and it becomes really confusing to figure out on a molecular level. But that's why we rely on human perception, because we're not quite ready to do it just on the bioassay level. We have to taste it, every ingredient still. So next slide, please. Okay, so now into how we go about doing this. That was just a little bit background about taste and flavor. But for taste research, we have different areas that we are divided into. So R&D, which is where I am, and we have 3 different R&D programs focusing on fermentation, botanical research, and also chemical synthesis. And then we have the innovation programs, which help us decide what areas we need to work in, because those are more market-driven areas of need and value. And then we have creation and design. And that's where all the molecules and extracts we make are applied into food ingredients to test whether or not they work and what applications they work. And that's where the flavors are created. So next slide, please. So it's a lot of tasting, but it's not just the molecule and the basic taste, but the mouthfeel. We investigate how all these ingredients interact in all of this space. So on the next slide, we have so many capabilities at IFF that we tap into, but the one that we focus on in my group is natural products chemistry, sensory, analytical chemistry, and then process engineering for scale up. So we have capabilities to develop new ingredients ourselves. And then we have a lot of platforms, which is where they apply. So for us, it would be modulation and taste ingredients. So I'm going to go a little bit into what we do for the taste ingredients and modulation R&D programs. As I mentioned, we have food science, and that's where we do fermentation research. We do microbial strain engineering so that we can use those biochemical pathways to produce our target ingredients. We do botanical research, taste-guided isolation to identify compounds and extracts that have that function. And then molecule discovery is where we might even design the molecule based on structural interaction and then synthesize them. Or we can go back to our other research programs to find them in nature, to ferment them. So we have 3 different programs that focus on 3 different areas of expertise to discover and develop new technologies and flavors. Next slide, please. Okay. So this is kind of the where we start slide. How do we start? So I kind of go from small to big. So on the smallest level is we look at structure interaction. So I mentioned the taste receptors and all the molecules that we may know that has a specific effect. So with that, we can map out and correlate which molecules and their chemical space, and then design the molecules of interest and look for them. Another area of how we start may be looking at a molecule to start with, and then similar analogs in natural or chemically synthesized arenas, so that we can cover that chemical space and determine where the best target might be. Then using metabolomics, we do molecular networking to understand what are the chemical identities and related structures that we can work on. Go back one slide, please. Can you go back one slide, please? Thank you. And then as we go into metabolomics and then bioexploration in the grander scale, as you all know, similar plants may have similar compounds. So we'll explore and expand into similar species on the plant level, but also on the microbial level if we're looking at the fermentation strains. And then ethnobotany, which is what we all do and know very well, our human interaction with them, and specifically edible plants, and anything that we've tasted, maybe initially for medicinal, maybe initially for food, just having that knowledge as an idea of where to start. So through all of these areas, we will focus, we can target where to look first and how to start our research. So in the next slide, I'll just go through the process, but you are all very familiar with the bioassay guided process. Next slide, please. So we found a plant, we're gonna extract it, and instead of tasting it, putting it in a bioassay, we taste it in solution, and that is something that is very different from the pharmaceutical research and chronic disease research typically. We have to make sure we extract it in a safe way, and also actually remove the solvent and investigate whether or not the plant could be toxic. If it is, we typically don't use it anyway because it wouldn't pass through regulatory, but we may analyze it for our interests. Then we do taste-guided fractionation, literally tasting each fraction to determine where our active molecules are. And then the other way of identifying active molecules is through metabolomics and correlating that with our sensory research. So that's targeted isolation. And then once we understand the active compounds, whether they be the first active compound that we started with, but most of the time, we identify compounds that are new and different. And though the compounds occasionally are novel, most of the time they're compounds that are already known, but nobody has identified it for this taste modulation function. And that's where the novelty and use comes in. And so we can file IP and patenting on that. So we can optimize the process using enzymes, various extraction methods, fermentation, or synthesis to find the best route, the most cost-effective production route for our company. So that is the discovery and development process that we typically go through. Next slide, please. So this is just kind of the overview, right? Here's a whole bunch of plants that we source, bioexploration, which is really why I'm partly here today, to understand and see what other plants we might be able to explore and obtain and identify these interesting taste actives that I just explained through our process. And then it's through all of this and layering the information from mass spec chemical profiles, sensory evaluation, to target our next set of molecules and discover. Okay. Within the company, so I talked about our whole process, but we do have a workflow. Yes, we dream, everybody dreams and comes up with ideas from where to start, but then we with all those ideas, we screen. So literally that is tasting by my group, and also the groups later on, because the flavors are the group that use it, and flavors are very specialized, trained technicians that know exactly what molecule does what, and they can kind of put the ingredients together in a way that makes it balanced. So we have flavors and we have perfumers on the scent side. So you can think them as very skilled painters that know exactly how to mix and blend everything to create the product that has the right flavor. So then when we screen it, we include flavors, and then we develop it by optimizing the process, but we also benchmark it against existing technologies to make sure that it's something novel, and we validated them in applications. So next slide. So just trying to put all of these together. Yes, we identified a specific extract or molecule, but that's just one ingredient. So it doesn't say specifically when you buy a product what ingredients there are, but it will say flavors or natural flavors or artificial flavors. And that's typically a mixture of maybe 10, 20, 50 ingredients that somebody had to put in there and decide that it was necessary. So it includes looking at the sweetness, the mouthfeel, and balancing all of those basic tastes. So even though we work on developing one extract or molecule, a key is that the flavors then know how to use it and then deliver that flavor formulation to our customers. So it's quite a complex network of how everything is put together, and we hence are a large company and working as a big team. So thank you, and this is kind of what we call the heart of innovation. People all working together and really innovating, because yes, maybe the plants you are aware of, the molecules we know, but how to use it and how to use it together and deliver it throughout the world in our products. And I look forward very much to applying this natural products chemistry with everybody here and seeing where the research could go, because this is a very wealth of botanical diversity that we can definitely tap into. So last slide. Thank you very much. So IFF's slogan in the taste part is taste like joy. So making joy through science, creativity, and heart. Thank you.
Please have a seat here, Dr.
Oh, you want me to sit there?
Thank you very much, Dr. Cheng, for the explanation. As a disclaimer, I'm not a from pharmaceutical science, but I'm a practitioner from agriculture field that specialize in producing citronella oil. So from your explanation, I can absorb that definitely aroma change our lifestyle, aroma influence our lifestyle, and that's how we understand that some of our communities remain small, remain slim because of their way of choosing aroma and remedies. And some of communities remain a little bit big because of the certain food they accustom the children from through generations. We will take question and answer later after our second speaker. And now please join me to welcome Professor Dr. Muhammad Irsan Saleh, who's going to present from away. I think he's already in Zoom. Can you please, the organizer, please, yes, present his CV, his resume first. Professor Dr. Muhammad Irsan, are you with us?
Yes, I am, but I cannot share my presentation here. Could host give me allowing participant to share the presentation?
Okay, okay. I think it's on progress now. Okay. Can you see your presentation now, Professor? Okay, the time is yours.
Okay, thank you very much. Good morning, ladies and gentlemen, esteemed colleagues, distinguished professor.
Recording stopped.
And fellow researchers from around the world. It is a pleasure and an honor to me and to our institution to join you in third international conference on natural product and chronic
Recording in progress.
2025, where we get to discuss innovation and strengthen global health and promote sustainability. Today, I'm delighted to share our research entitled The Natural Antifibrosis Potential of Anthocyanin in Ipomea batatas Against the Transforming Growth Factor Beta Type 2 Receptors. This presentation, this represents an effort to integrate ethnopharmacology, natural product chemistry, and modern computational approaches, which the broader goal and identifying safer and more effective antifibrotic compound. Okay, as a background, fibrosis is a pathological process characterized by excessive accumulation of extracellular matrix component, leading ultimately to organ stiffening, impaired function, and chronic disease progression. It involves in wide range of conditions such as chronic kidney disease, liver cirrhosis, pulmonary fibrosis, cardiac remodeling, and diabetic complication. And one signaling pathway consistently implicated in these processes is the transforming growth factor beta or TGF-beta pathway. Within this pathway, the TGF-beta type 2 receptor or TGF-beta receptor 2 acts as a crucial upstream regulator. And when TGF-beta binds to TGF-beta2 receptor, it triggers phosphorylation and downstream molecule, especially SMAD family, and lead fibroblast activation and extracellular matrix accumulation. And because of this central role, the TGF-beta receptor 2 has become a prime therapeutic target in fibrotic drugs development. And currently some antifibrotic agents have been used, but significant side effects were identified, so rising the risk of complication and mortality and ineffective treatment. So Ipomea betatas or purple sweet potatoes has been consumed across Asia and Pacific Island. And importantly, the purple varieties contain of high concentration of anthocyanin, a subclass of flavonoid responsible for the fibrin purplish pigment. Anthocyanin are known for their antioxidant properties and also anti-inflammatory effect and free radical scavenging capability, and also potential antimicrobial and anti-cancer effect. And more recently, evidence that anthocyanin may modulate fibrotic pathway through exact molecular interaction remains largely unexplored. This inspire our question: can anthocyanin from Ipomea batatas as a natural inhibitor of TGF-beta receptor 2? So we provide in silico method as a fast and cost-efficient way to predict antifibrosis biological activity before we go to the wet lab. The objective of the study to evaluate the antifibrosis potential of the purple sweet potatoes anthocyanin. And we all know that antifibrotic potential of anthocyanin has been reported from previous study. Anthocyanin from Ipomea batatas, besides provide as anti-inflammatory and antioxidant agent, it also renoprotective effect relevant to fibrosis and potential to modulate key pathway of TGF-beta. So anthocyanin can be provided as anti-fibrotic candidate. Our main objective to evaluate the inhibitory potential of anthocyanin against TGF-beta2 receptor using in silico approaches, especially by in virtual screening, molecular docking, absorption, distribution, metabolism, excretion, and toxicity analysis, drug likeness evaluation, and also move water molecule. And then added hydrogen atom, corrected missing, ligand preparation, and then we go to ligand preparation, docking simulation, interaction analysis, and ADMA and toxicity drug likeness assessment. This approach lower risks of drug-drug interaction and have a better safety when we co-administer with other medication. In contrast with the perfenidone here as a control, perfenidone does not inhibit cytochrome P450 enzyme, and it metabolized by cytochrome P450 CYP1A2, increasing drug interaction risk. So from the interaction, we know pharmacokinetic properties, anthocyanin is better than perfenidone. This is the lipophilicity and water solubility, and we found here that the anthocyanin indicating lipophilic properties. So it can penetrate lipid bilayer cell membrane, and anthocyanin still allow for further study to develop parenteral anthocyanin administration because of as Belu is look at the moderately soluble. This is the drug likeness when anthocyanin and perfenidone. When we evaluate the drug likeness assessment, we use Lipinski and use Gose as assessment evaluate. We look here that pelargonine 3-glucoside show only one violation to Lipinski's rule, making it the closest ideal to ideal drug likeness. and several anthocyanins fully comply with GUSI criteria, indicating strong potential as a lead compound, while the moieties of sugar moieties may reduce permeability, but they also stabilize the molecule and contribute to receptor binding. This is the toxicity and medicational analysis. With PROTOX2 toxicity prediction, reveal anthocyanin have LD50 is approximately 5,000 milligram per kilogram body weight. So toxicity class 5, it means that the lowest toxicity category, but perferidone has LD50 500 and so it's more toxic. This indicates at higher doses, reinforcing us sustainability as natural therapy candidate. When we use pain criteria, pan-assay interference compound, reveal 3 of anthocyanin derivative, piogonin, 3-glucoside, pelargonin, 3-glycoside, pionidine, cyanidine, and control perferidone have pain score 0. That means no interferon motive, or they have good at DMT. Yeah? So it's not toxic. And
Prof. Irsan, are you still with us? Okay, now we proceed with the question and answer session. Maybe please the committee can go back to the person that was about to raise a question from my one from my right side. Iya. Silakan Ibu.
Thank you very much, Dr. Chang. I have 2 questions. The first one is, it's interesting that to find the active ingredients is to see the interaction with the receptors. That's something new for me. And my question will be, to what extent the IFF will do the toxicology testing to see if that new compound is safe. And then the second one is, if, for example, the flavor is categorized as GRAS means like the generally regarded as safe. So what is the criteria or the data that support to be categorized as safe. And the last one, I'm sorry, I have another one. For the flavor, is there any pharmacovigilance kind of studies, for example, after it being in the market, whether it will be evaluated in terms of the toxicity? Thank you.
Thank you for your question. Yeah, so initially when we start out, we try to kind of classify the botanical ingredients and also the molecules that we target. So at least for botanical research, we try to select botanicals that are used or ingested already, so things that are edible. And when we extract with safer solvents, typically just water and ethanol. But everything is about the dose, right? So when we're tasting, we're only tasting at around 100 ppm or so. And initially, it will be sip and spit. But if you're extracting a food from a food ingredient, there's really low risk in that. But we do evaluate whether or not it is indeed a food of low risk, and from the part that is ingested, so that one would be the lowest barrier. If it's a plant that's not ingested, but maybe consumed as a tea, consumed as a medicine at specific levels, that's when we do a little bit more further into investigation of potential for toxicity. And we do have toxicologists at IFF, and we also research into whether or not they're used as food or flavors around the world and globally too. And I mentioned the toxicology, but also we'll send it out for analysis in terms of micronuclear assays and genotoxicity, and if needed, animal studies and clinical trials if that's needed. So we can go through all the routes, and obviously it's most cost effective to not have to by using ingredients that are food. And so we really don't want toxic effects at all. Not only will it be unsafe, but it's already going to be a challenge for the food and flavor industry. So usually those are really low on our priority and not what we're looking for. So part of that is screened out really early on. So if it's ingested as medicine already, like areas in which there's a long history, then that's kind of, well, we kind of have the answer, and oftentimes there are already studies published on those molecules and those extracts. So we use those as leads, but certainly we do go over that. For FEMA grass, yes, there's different types of FEMA grass. There is one for flavors. It's also called FEMA, Flavor Extract Manufacturing Association. So that is an industry guided review of scientists that look at the new extracts that we're proposing to be used as flavors. So note, it is for evaluation of its safety as consumed. So they'll ask us for chemical analysis and also for use levels and what's the max dosage. So all of that is taken into consideration before new ingredients are approved for use in industry. So that's namely for US, but then a lot of other countries will follow that guidance. Different countries also have their specific guidances. Indonesia is quite particular, and you have a list of botanicals that are accepted. And sometimes we have to just request and provide all the data and information to show that it's safe, and then have it be added to the list for Indonesia. Countries like South Korea have their own list, and there's actually no mechanism for introducing that for foods that they don't have. So it's really quite complex globally, but we do have mechanisms to make sure that it is safe to consume. And then your last question was about whether or not we look at safety after it's in the food product. If there's a problem, yes, but we really do all that we can to make sure we don't introduce an ingredient that could be have a particular issue after we've deployed it. So we would if that happens, but currently all the mechanisms are for preventing anything that could be potentially hazardous from going into our food system. Yeah.
Okay, we can take the next questions, and perhaps the committee can confirm to Professor Irsan whether he can available to take question or not. He's available. He's with us now. Okay, Professor Irsan. Oh, he's not available. So the question will be addressed to
like just bitter or just sweet, things like that.
Yes, definitely taste is subjective, and as I showed with the complexity of something like bitter taste, I will say one thing, and then somebody will be completely different, and that's really due to the better receptors that we have that are expressed that are different for everybody. When we do our screening, it's initially, yes, just a few people who, the scientists that initially work on it. But for the basic tastes, at least for sweetness and saltiness, everybody can pretty much align and agree on that. So we do have sensory tests every year or so for our scientists and people who work on it to make sure and calibrate us to show that, yes, we can detect it and another one doesn't care for it at all. There are a lot of differences, and that subjectivity is taken into account by having what we call global ambassadors that taste and evaluate all the products.
Is there any other questions? Okay, shall we close this session here? Okay, I think we can wrap this session as it is. Thank you very much. Yes, oh, we still have, okay, we'll take one more question. From my left side, thank you.
Okay, thank you for Dr. Cheng. I want to ask for you, what is the effect of micro and sculpture technology on flavor stability and control release in functional of breathes? Sorry, my name is Dora Briskila in Biologi Universitas Nasional.
Can you repeat the question? I couldn't understand.
Okay. What is the effect of micro and scalpelation technology on flavor stability and crottal release in functional beverage?
Sekali lagi boleh, Mbak?
Okay. What is the effect micro and scalpelation technology on flavor stability and control release in functional beverage?
Micro
and encapsulation.
Okay, so you're asking what is the effect of microencapsulation in flavors?
Yes.
Okay, microencapsulation, it can be controlled release, so it really depends on what it is we're looking at. But we want to sometimes encapsulate an unstable flavor using small chemicals that kind of can wrap and surround it into a sphere. You can then have the flavor be protected, and then maybe, for example, an application of this might be in tea bag flavors. So in a tea, you have your leaves, but also if you add an encapsulated flavor to it, it will be released upon dipping it into hot water, and then the flavor will be released. So this is like a controlled release, whereas if you just left aromatics in the tea, it slowly dissipates constantly, and the shelf life is less. So that's one application in which we might use microencapsulation in flavors. Another area might be like chewing gum. If you had chewing gum with little bursts of flavor and you crunch on it, it gets released. So that's another way of changing the delivery system of flavor ingredients.
Thank you so much, Dr. Cheng. Okay, thank you. Any further questions? No, okay, I think we can wrap it here. We have another. Oh, Professor Irsan is here. Professor Irsan, are you with us?
Yes, okay. I'm with you. I'm sorry.
Yes, we are on the Q&A session now.
Okay.
I thought we lost you. Okay. Ada pertanyaan mungkin? Is there any question to address to Professor Irsan here? Okay, I think it's a wrap here. Thank you very much. Thank you to Professor Irsan and Dr. Cheng for presenting the very insightful. I enjoy it here. I really enjoy it here. And I hope all the audience can feel the same about it. Maybe I can just return the time, stage and time to the Master of Ceremony. Thank you very much for your commitment on this session. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much to our moderator, Dr. Konita Basalamah, and also our invited speakers, Dr. Diana Klazercheng, International Flavors and Fragrance, United States, and also Professor Dr. Muhammad Irsan Saleh, M. Biomed from Universitas Sriwijaya, Indonesia. Ladies and gentlemen, the next session is token of appreciation session to our distinguished invited speakers in session 1. We would like to invite Dr. Diana Klazercheng, International Flavors and Fragrance, United States. You may come forward to the stage. And we would like to invite Professor Dr. Ernawati Sinaga, MS APT, to come forward and present the token of appreciation to Dr. Diana. International Flavors and Fragrance, United States, and also our online speakers, Professor Dr. Muhammad Irsan Saleh, M. Biomed from Universitas Sriwijaya, Indonesia. Thank you very much for your enlightening presentation and meaningful contribution to today's event. We truly appreciate your insight and the inspiration you have given to all of us. Gentlemen, once again, we would like to extend our deepest appreciation to our sponsors whose support has made this international conference possible. Our sincere gratitude goes to PT Indolab Utama, Lukagel, PT Plasma Unitek Global, Analisa Resources, PT Antam Tbk. Thank you very much for contributions. Ladies and gentlemen, we've now come to the lunch break session. On behalf of the organizing committee, we would like to express our appreciation for your active participation throughout this morning's program. Lunch has been prepared and is now ready to be served at the left side on this building. And we kindly invite all invited speakers to enjoy the lunch in VIP room. The next session will begin at 1 p.m., so we encourage everyone to return to the auditorium on time. Once again, enjoy your lunch break, and we look forward to seeing you back for the next session. Thank you.
Recording stopped.
Selamat siang Bapak Ibu rekan-rekan mahasiswa semua. Kami persilakan untuk menikmati santap makan siang yang telah disediakan. Untuk makan siang di sebelah sisi kiri prasmanan hanya diperuntukkan bagi panitia yang membawa name tag khususnya bagi para presenter yang telah hadir pada hari ini. Untuk mahasiswa, tamu undangan lainnya, makanan disediakan di meja registrasi di depan. Terima kasih.
Recording stopped.
Gatal karena infeksi jamur? Pakai Krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, Krim 88 kupas tuntas infeksi jamur.
Pakai luka gel aja.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Gatal jamur selangkangan, Krim 88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas, pakai Krim 88. Mikaya.
Gatel.
Gatal karena infeksi jamur? Pakai Krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, Krim 88 kupas tuntas infeksi jamur.
Pakai luka gel aja.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Gatal jamur selangkangan, Krim 88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas, pakai krim 88.
Mikaya. Gatel.
Gatal karena infeksi jamur? Pakai Krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, Krim 88 kupas tuntas infeksi jamur.
Pakai luka gel aja.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Gatal jamur selangkangan, Krim 88 solusinya. tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas pakai krim 88.
Gatal karena infeksi jamur? Pakai krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, krim 88 kupas tuntas infeksi jamur. Gatal karena infeksi jamur? Pakai krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, krim 88 kupas tuntas infeksi jamur.
Pakai luka jelajah.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas pakai krim 88.
Mikaya.
Gatal karena infeksi jamur? Pakai krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, krim 88 kupas tuntas infeksi jamur.
Pakai luka gel aja.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Gatal jamur selangkangan, krim 88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas pakai krim 88.
Mikaya.
Gatal karena infeksi jamur? Pakai Krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, Krim 88 kupas tuntas infeksi jamur.
Pakai luka jelajah.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Gatal jamur selangkangan, Krim 88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas pakai krim 88.
Mikaya.
Gatal karena infeksi jamur? Pakai Krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, Krim 88 kupas tuntas infeksi jamur.
Pakai luka jelajah.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Getol jamur selangkangan, Krim 88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas, pakai krim 88.
Mikaya.
Gatal karena infeksi jamur? Pakai Krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, Krim 88 kupas tuntas infeksi jamur.
Pakai luka jelajah.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Getol jamur selangkangan, Krim 88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas, pakai krim 88.
Mikaya.
gatal karena infeksi jamur? Pakai Krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, Krim 88 kupas tuntas infeksi jamur.
Pakai luka gel aja.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Gatal jamur selangkangan, Krim 88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas pakai krim 88.
Mikaya.
Gatal karena infeksi jamur? Pakai Krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, Krim 88 kupas tuntas infeksi jamur.
Pakai luka gel aja.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Getol jamur selangkangan, krim 88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas pakai krim 88.
Mikaya.
Gatal karena infeksi jamur? Pakai krim 88. Krim 88 tidak lengket dan cepat meresap. Dengan sensasi dingin dan aroma yang fresh, krim 88 kupas tuntas infeksi jamur.
Pakai luka gel aja.
Luka gel, cegah infeksi pada luka tanpa noda. Bunuh 99,99% bakteri dalam 30 detik. Luka gel, aksi cepat antiseptik luka.
Getol jamur selangkangan, krim 88 solusinya. Tidak lengket dengan sensasi dingin dan aroma yang fresh.
Selangkangan semua tuntas pakai krim 88.
Mikaya.
Good afternoon, ladies and gentlemen. We will start the session 2 in a few minutes. We would like to kindly invite all participants to enter the auditorium and be seated. Thank you. Good afternoon, ladies and gentlemen. Welcome back to the 3rd International Conference on Natural Products and Chronic Diseases 2025, Natural Products for Quality of Life, Advancing Global Health and Sustainability. I am Nisrina as your MC, and it's a pleasure to have all of you here today. We've now come to the next part of our event, International Seminar, the discussion session 2. We have 3 invited speakers for this session. Profesor Dr. Poppy Angelisa Zaitun Hasibuan, SSI, MSI, APT, from Universitas Sumatera Utara, Indonesia. Dr. Insinyur Nonon Saribanon, MSI, from Universitas Nasional Indonesia, and Dr. Vivitri Dewi Prasasti, MSI, from Universitas Nasional Indonesia. The session will be guided by our moderator, and now please welcome our moderator, Professor Dr. Sri Endarti Rahayu, MSI. The floor is yours.
Good afternoon, everyone. It is wonderful to see so many of you here today. My name is Sri Endarti Rahayu, and I will be serving as your moderator today. This session is about to get new information about the development of natural product to prevent and to treat chronic disease. You'll be hearing presentation from 3 distinguished speakers today. 1, Professor Dr. Poppy Angelisa Zaitun Hasibuan, SSI, MSc, APT. 2, Dr. Insinyur Nonon Saribanon, MSc, and 3, Dr. Vivitri Dewi Prasasti, MSc. Before the presentation begins, let's know the regulation, how the presentation will be going on. Firstly, I would like to give the time to each distinguished speaker to present material about 20 minutes. And then, after the presentation, we are going to have discussion session. Question and answer, we hope 6 or 9 questions from participants are enough. Now, moving along our session, please allow me to first welcome the first distinguished speaker, Professor Dr. Poppy Angelisa Zaitun Hasibuan, SSc, MSc, APT, to deliver presentation. Please join me in welcoming Professor Dr. Poppy Angelisa Zaitun Hasibuan, MSc, APT, with round applause. I think she is on Zoom right now. Yeah, the committee. Can you connect to Professor Dr. Poppy right now? Halo. Ada.
Halo, assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Profesor Dr. Poppy. Okay, Professor Dr. Poppy, who will be speaking to us about unlocking the potential flavonoid for colon cancer, a study of Vernonia ambiguina extract. Please allow me to read a brief biodata of Professor Dr. Poppy. Professor Dr. Poppy is Distinguished Professor from Faculty of Pharmacy Universitas Sumatera Utara, Medan, and now serves as a Vice Rector of Research, Community Service and Collaboration. Her area of interest is in ethnopharmacology and natural product, with a particular emphasis on examining and assessing the anti-cancer therapeutic potential of biological natural resources. Okay, Professor Poppy, time is yours.
Thank you, moderator. Let me share my screen. Can you see the slide?
Not yet.
Okay. Thank you to the committee that invited me to attend this conference. My talk is about unlocking the potential of flavonoid for colon cancer, a study on Vernonia amygdalina extract. Colon cancer is a global health burden. Why? Because according to the statistic, it has become second leading cause of cancer related death worldwide. Colon cancer develops through the accumulation of genetic and epigenetic alterations that transform normal colonic epithelium, become adenoma, and then carcinoma, and lastly become metastasis sequence. The most common drivers of mutations are APC as a first early event, and then continue to KRAS, and then continue with TP43 mutation at late event, which can impair apoptosis and genomic stability that will become transition to carcinoma. The CMS classification captures the molecular heterogeneity of colorectal cancer by integrating gene expression, genomic, epigenetics, microenvironment, and signaling pathway. If we compare with another cancer, colon cancer has become the fourth most frequent cancer in the world. The prevalence occurs in both male and females. In males, colon cancer is the second most common cancer with a percentage of 11.6%. Colon cancer does not have a single cause. It develops through the interaction of genetic, both acquired or inheritance, environmental, lifestyle like smoking, heavy alcohol use, obesity, and physical inactivity, and biological factors that drive mutation. This is most common. And then the important is inflammation and gut microbiome and dysbiosis. Conditions that cause long-term inflammation in the colon increase cancer risk. For example, the condition ulcerative colitis and Crohn's disease, the inflammation mediators like NF-κB, stage 3, COX-2, and interleukin-6 will increase cell proliferation, angiogenesis, and decrease apoptosis. This diagram shows how chronic inflammation contributes to cancer development and progression through multiple biological mechanisms. Chronic inflammation produces reactive oxygen species, reactive nitrogen species, and epigenetic change. These cause DNA damage, alter gene expression, and immune dysfunction, which promote cancer growth, invasion, angiogenesis, and metastasis, and also immune evasion. The gut microbiome plays a critical role in immune regulation and metabolism. And then how chronic inflammation leads to colon cancer. Firstly, persistent inflammation like inflammatory bowel disease, infection, leads to continuous epithelial injury, and then the immune cell produce pro-inflammatory cytokines, which produce harmful molecules that damage DNA and surrounding tissues. And then the reactive oxygen species cause mutation, and reactive nitrogen species promote angiogenesis that could induce DNA damage. And of course, inflammatory cytokine can suppress the immune system, helping cancer evade detection. And the fifth is chronic inflammation, weaken tissue barriers and stimulate enzymes that help cancer invade surrounding tissue. The consequence is disrupt gut microbiome, become carcinogenic metabolites. And then DNA methylation change epigenetic alteration that can silence tumor suppressor gain and activate oncogenes. The key problem in the treatment of colon cancer, first, is late diagnosis is one of the biggest problem in colon cancer, because most colorectal tumor grow silently for years before causing symptoms. By the time symptoms appear, the disease is often already advanced, so more difficult to treat and more likely to have metastasize. And then limited benefit of immune therapy is a key problem also, because most colon cancer are immunologically cold, poorly infiltrated by immune cells, and resistant to immune activation. And then treatment toxicity, of course, drug resistant treatment toxicity become a problem, because the therapies that are most effective at killing tumor cells often also damage healthy cells, especially those that divide quickly. This leads to a range of harmful side effects that affect patient ability to tolerate treatment, complete therapy, and maintain quality of life. And then microscopic cancer, poor detection of minimal residual disease, because of microscopic cancer cells remain even after curative surgery. Surgery and chemotherapy can remove the visible tumor, but tiny cluster of the cancer cell may remain in the blood. So not only in the blood, lymph nodes, or distant tissue, these cells are too small to be detected by the CT scans, MRI, colonoscopy, and tumor marker like CEA. And then finally, lastly, high recurrence rates of are major of in colon cancer treatment too, because even after successful surgery and chemotherapy, microscopic cancer cell often remain undetected, eventually going into recurrent or metastatic disease. The cancer usually treated by a combination therapy, for example, FOLFOX, FOLFIRI, because combination therapies targeting different pathways. Natural products such as flavonoid is a promising candidate for synergistic cancer therapies, because they have diverse therapeutic effect and mechanism of action. Synergistic effect is needed because they have diverse therapeutic effect and mechanism of action. So because the synergistic effect is needed, because single agent treatment are rarely enough to overcome the complexity, adaptability, and heterogeneity of cancer. So cancer is not driven by one pathway, but by multiple overlapping pathway. And so combining therapies that work together produce far better results than one treatment alone. Many reference has announced that there is a significant focus on the therapeutic potential of flavonoid for the colon cancer management. Flavonoids are valuable in synergistic cancer therapy because they target multiple cancer hallmarks, enhance the effect of standard treatment, and reduce treatment-related toxicity, something most conventional drugs cannot do alone. They act like a biological multi-tools that complement chemotherapy, immune therapy, targeted therapy, and radiotherapy. For example, the flavonoids that I present in these tables, like fisetin, curcumin, and so on. And then this is the chemical structure of flavonoid. It is a phenolic compound characterized as derivatives of 2-phenylbenzogammapiron, consists 15 carbon atoms arranged in 2 benzene rings, referred to as A and B rings, connected by an oxygen-containing pyrene ring, C ring, and categorized into 6 main groups, which is flavonols, flavones, isoflavone, anthocyanin, based on chemical structure, oxidation level, and chain link unsaturation. Flavonoids act through multiple biochemical and molecular mechanisms because they are pleiotropic polyphenol. So what is a pleiotropic polyphenol? Flavonoid called pleiotropic polyphenol because it has multiple target mechanisms, so we call it pleiotropic. So flavonoid can affect many molecular targets because flavonoid do not work through a single receptor or pathway. Instead, they influence multiple protein, enzymes, and signaling cascade. And then a flavonoid produce many biological activities simultaneously, as we know that flavonoid can act as antioxidant, anti-inflammatory, anti-cancer, and many effects. And flavonoid can modulate gene expression, so it changes the activity of multiple transcription factors like NRF2, NF-κB, and P43. And flavonoid chemical structures enables a broad interaction that allows them to bind to different protein, chelate metals, scavenge free radicals, and insert into cell membranes. Flavonoids come from many natural sources, but they can be grouped into 6 major categories of source, as I said before. We can classify source of flavonoid into 6 major groups, like fruit, vegetables, beverage, herbs and spices, and legumes and cereals, and nut and seeds. That's 6 main source. So if we see that fruit can apple, berries, citrus, grapes, onion, and many source. And then flavonoids are considered multi-target anti-cancer agents because they do not act on only one pathway like many drugs. Instead, they hit multiple hallmarks of cancer at the same time. So it can act as antioxidant and pro-oxidant, induce apoptosis on cancer cell, can arrest cell cycles, and modulate the autophagy. The flavonoids targets the signaling pathway by inhibiting modulating, suppressing, and blocking different pathways. For example, quercetin can inhibit WNT beta-catenin pathway that can prevent uncontrolled cell proliferation, and it can modulate the NEPK pathway that can influence cell proliferation and apoptosis. Could reduce cell survival and growth by suppressing PI3K AKT-mTOR pathway, and then like curcumin and epigallocatechin galat could block the NF-κB pathway as a major anti-inflammatory mechanism that can reduce the pro-tumorigenic cytokines. This is pathway. Flavonoid can bind to the growth factor receptor so that the signalization pathway to activate PI3K cannot occur. The activation of mTOR cannot activate it to increase cell proliferation. So modulating cell response, because AKT activation can lead some several outcomes like increased translocation of GLUT4, enhancing glucose uptake, increased cell survival, inhibition of FOXO1, and activation of mTOR, which is increased cell proliferation and decreased autophagy. If the flavonoid could induce the growth, the receptor, so the mTOR could not increase. And then this slide shows the blocking of NF-κB signaling pathway by flavonoid. Flavonoid block the activation of IKK. IKK is IKB kinase. Is a key role on NF-κB signalization, and then prevent the degradation of IKB and directly inhibit the movement of NF-κB into the nucleus. By this action, flavonoid reduce the ability of NF-κB to activate genes that promote cell proliferation, survival, and inhibit apoptosis, potentially exerting anti-inflammatory and anti-cancer effect. And flavonoid can modulate the gut microbiome by reversing dysbiosis. Flavonoid can disrupt bacterial cell membranes that inhibit enzymes critical for bacterial replication and promote beneficial commensal bacteria. And then flavonoid also increase the abundance of microbes that ferment dietary fibers into short chain fatty acids like butyrate. This is important because butyrate directly inhibits cancer cell proliferation and induce apoptosis and reduce chronic inflammation. And flavonoid could also reduce gut inflammation by regulating immune response. This is a specific flavonoid that have mechanisms of action to reduce colon cancer activity, like quercetin, luteolin, apigenin, epigallocatechin galat, and genistein. And next, this is our study. This study evaluates the therapeutic efficacy and safety of Vernonia amygdalina extract in treating colon cancer induced by azoxymetan dextran sulfate sodium in mice, and to elucidate the underlying mechanism. Our study starts with the extraction of the Vernonia amygdalina leaves by maceration method, and then continue with in silico study, and then in vivo. We did not the in vitro study because the data of IC50 already we have, and The in vivo study utilized a mouse model of colon cancer to assess the impact of Vernonia extract on pathological markers, inflammatory mediators, and oxidative stress. And we choose the AOM-DSS to do the in vivo study because that models, for inducing colon cancer in animal is well-established protocol that stimulates the human condition of colon carcinogenesis. This model overcomes certain limitation of other models by reducing the latency period for tumor development. Even there is three experimental colon cancer models like xenograft models and genetically engineered mouse model, but the IOM-DSS models is well-established model for inflammation-driven colon cancer, and many literature has used this model, like example that I put in this slide. And then phytochemical profiling of Vernonia amygdalina ethanolic extract using LC-HRMS. It showed that Vernonia amygdalina consists 30 biological compounds, and the flavonoid consists of cinnarosid, rhamnethin, and luteolin. We found 3 flavonoids on the Vernonia amygdalina extract. And then we did the in silico study. This is the data of protein interaction result. Protein interaction related to colon cancer and Vernonia amygdalina ethanolic extract. And on part A shows a Venn diagram indicating a significant overlap of 270 proteins between Vernonia amygdalina ethanolic extract and colon cancer. And then part B appears to contain a list of target genes, amygdalina ethanolic extract. And then this is the data for genes and genomes. The first A reveals a substantial fold enrichment in KEGG pathways. It notably in, as we say, notably in steroid hormone biosynthesis and EGFR tyrosine kinase inhibitor resistant, underscoring their pivotal roles in disease etiology. And the B part is B enumerates enriched GO gene ontology, biological process with an emphasis on cellular response to various stimuli, and reflecting dysregulated cellular signaling mechanism. In C elucidates enriched cellular component with a mark present in presynaptic membrane and dendritic structure, indicating altered neuronal component. Lastly, D focus on molecular function, where kinase and binding activities predominate, hinting at the disruption of signal transduction and molecular interaction. So relatively, this data suggests a complex molecular interplay within colorectal cancer and colon cancer and Vernonia amygdalina ethanolic extract pathogenesis, with the fold enrichment and min log 10 FDR, which could, the value quantitatively emphasizing the significance of this biological pathway and function, which could inform targeted therapeutic strategies. The result of the protein-protein interaction analysis indicate that that Vernonia amygdalina ethanolic extract plays a crucial role in inhibiting inflammatory marker proteins such as cyclooxygenase 2 and interleukin 8 and NF-kappa B. Therefore, we have selected these proteins to analyze the binding interaction between Vernonia amygdalina ethanolic extract component like betain, rhamnetin, ecinenon, luteolin, and latifolin with inflammatory protein involved in CR in colon cancer like cyclooxygenase 2, interleukin 18, interleukin 8, and NF-kappa B. And then this is the data of in vivo study. Administration of different dose of Vernonia amygdalina as P1, P2, and P3 demonstrated notable effect on colon length in IOM-DSS induced colon cancer mice. Although Vernonia amygdalina ethanol extract did not fully restore colon length to that of the control group, it significantly attenuated the reduction observed in the induced cancer group. This suggests that even a relatively low dose of the extract may have beneficial effect on colonic health. Higher dose of Vernonia amygdalina ethanolic extract like P2 and P3 exhibit more pronounced effects on colon length. They not only mitigated the reduction in colon length, but also restored the length to those observed in the control group. The IOM-DSS induced colon cancer mice exhibited decreased body weight compared with the control mice, which is consistent with cachexia associated with advanced colon cancer. So, Vernonia amygdalina ethanol extract administration also affected body weight in AOM-DSS induced colon cancer mice. The lowest dose of extract increased body weight in the induced cancer group, although it did not fully restore body weight to control levels. Higher dose of the extract like P2 and P3 were more effective in preventing body weight decline and maintain body weight closer to that of the control group, indicating a dose-dependent response similar to that observed for colon length. Yeah, this finding suggested a dose-dependent response, indicating that higher concentration of the extract may be more effective in preserving colonic health. And then this study assessed several parameters, including the levels of interleukin 6, interleukin 1 beta, interleukin 10, and TNF alpha in the colonic tissues of the experimental group to evaluate the effect of extract on inflammation in the colon cancer microenvironment. The extract exhibit anti-inflammatory effect in the IOM-DSS induced colon cancer model by modulating the level of interleukin 6, interleukin 1 beta, interleukin 10, and TNF alpha. The ability of extract to reduce interleukin 6 and interleukin 1 beta levels suggests its potential to suppress inflammation, while the increase of the interleukin 10 levels and decrease in TNF alpha levels indicate its immunomodulatory properties. And this is the data for the TGF beta, MMP9, and PEGFR also showed the reduced the level of them. This is the data of histology of colon tissue. In the normal mice, the colon tissue exhibit the expected structure with well-organized epithelium and crypts. In contrast, the AOM-DSS, as we see in this slide, the C group, display significant disruption indicative of injury or disease, presumably as a result of the azoxymetan dextran sulfate sodium treatment, which is commonly used to induce colitis and colon carcinogenesis in mice. The C plus group show tissue with picture suggesting some recovery or protective effect from quercetin treatment. And then the subsequent P1, P2, and P3 group show progressive structural change with increasing dose of Vernonia amygdalina ethanolic extract and experimental therapeutic agent. Notably, P3 demonstrates an improved architecture compared to C minus, suggesting that higher dose of Vernonia amygdalina ethanolic extract may convey protective or regenerative effects to the tissue damage by induced by IOM-DSS. This observation may suggest dose-dependent efficacy of Vernonia extract in mitigating the harmful effect of AOM-DSS on colon tissue. Finally, this is as a conclusion, flavonoid represents a promising opportunity for the development of effective colon cancer prevention strategies, and the synergy of flavonoids with existing chemotherapeutic agents and their capacity to modulate various signaling cascade reveals an intricate network of interaction that could be harnessed to impede cancer progression. Vernonia amygdalina ethanolic extract rich phytochemical profile, including anti-inflammatory, antioxidant, and anti-neoplastic properties, effectively mitigated key colon cancer or colorectal cancer markers. And the Vernonia amygdalina ethanolic extract demonstrated a favorable safety profile with no adverse effect on vital organ biomarkers. So this brings us to the end of the slide. Thank you. I pass the screen to the moderator. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Poppy, for giving such informative and interesting presentation. Ladies and gentlemen, let me welcome the second distinguished speaker, Dr. Insinyur Nonon Saribanor, MSc, to deliver her presentation. Please join me in welcoming Dr. Insinyur Nonon Saribanor with a round of applause, please. Dr. Nonon Saribanor, who will be speaking to us about from forest to product, ecological basis for the commercialization of Pycnarena longifolia in Tanah Tidung.
Share. Okay. Our research is on Sengkubak. Sengkubak is Pycnarena longifolia. This is one of the endemic species of Kalimantan. We can find Sengkubak in all over Kalimantan, from north to south, from east to west, west to east. And I would like to introduce Pycnarena longifolia, a plant of considerable traditional significance in several regions of Indonesia, especially in Kalimantan, but also found a little in Jambi, Sumatra. Taxonomically, this species belongs to Menispermaceae family, and which is known of its diversity of plants containing bioactive compound, then often used as a traditional medicine. And locally, this plant is known as sengkubak in Indonesian and Malaysian language, and also tubu, apak, sangsang. It's another local name usually used by Dayak tribe in Kalimantan. And the unique of this plant is the leaves is particularly used as unique savory flavor. We can boil the leaves maybe with another substance, another herbs for 30 minutes maybe, and we can consume the extract and the aromatic compounds will appear. In addition to culinary uses, the sengkubak also plays a role in traditional medicine, especially in Dayak tribes, as to reduce fever, alleviate headaches, and also prevent skin disease and so on. Next. The morphological characteristics and ecological preference of sengkubak is the sengkubak is liana, so they described as a slender twining shrub and also distinctive climbing growth habit. That's one of the specific of liana, and its structure is naturally adapted for vertical growth, so it is need a structure or tall trees to climb, and also as support structures, and its preference for the environment where upper canopy lights also more accessible. And sengkubak commonly occurs at the elevation in lowland or in a hilly ecosystem from 500 to 1,500 meters above sea level, and in the humidity levels quite high. So this is the specific of sengkubak that we want to know more. Next. Sengkubak have a traditional application as natural umami source. This is a very interesting role of sengkubak. We know that the umami source and the term umami originating from Japanese literally means delicious flavor. It refers to the savory taste distinct from sweet, sour, salty, and bitter. And this taste is closely associated with glutamic acid and nucleotides such as inositol and guanylate. And sengkubak leaves naturally possess a strong savory flavor and rich in amino acid, particularly glutamic acid. This makes the plant a valuable natural alternative to synthetic flavor enhancers. And beside that, also sengkubak provides natural substitutes for monosodium glutamate, also enhancing appetite. nutritional intake, and overall quality of life among the elderly. Next. This is the highlights of nutritional value of Sangkubak based on proximate analysis and the composition. So I think we can see that Sangkubak, besides as a natural for enhancer, also has the role as nutritional source and have a high antioxidant ingredients. Next. Next slide, please. So this is this result highly that Sangkubak has promising nutritional potential as both as culinary ingredient and also as supplementary nutrient source. And this provides a scientific basis for promoting its use in food products, especially in rural or under-resourced communities where nutritional support is crucial. Next. Our research conducted in North Kalimantan, we emphasize on ecological condition of Sangkubak, and with 4 plot-based line insect transect methods, we assess the vegetation structures and also environmental parameters. And to reach the how we discuss the situation, we also done qualitative approach with in-depth interview and FGDs. Next. This is the microclimatic conditions in Sangkubak habitats at 4 plots in North Kalimantan, and this shows that temperature across all sites range from approximately 30 to 34 degrees Celsius, and forming a relatively warm environment typical of lowland tropical forests, and humidity varied between 43 and 55%, indicating moderately moist conditions, and the light intensity differed substantially from shaded forest areas to more open canopy section, and ranging from under 400 lux to nearly 8,000 lux. These variations suggest that Sangkubak is capable of surviving under a broad range of microclimatic conditions, particularly tolerating both shaded and partially open environment. Next. This is the vegetation structure in Sangkubak habitat, and also the density of the plants there. And we recorded relatively dense vegetation layers, approximately 260 trees per hectare, and 300 poles, and more than 2,000 saplings, and more than 1,800 seedlings per hectare. This high density, particularly at the seedling layer, indicates that vigorous forest regeneration is the habitat of Sangkubak. Next. This is about the diversity of the ecosystem where the Sangkubak growth. This slide covers the diversity patterns, what we have in in-depth interview and also in FGD, that after we explore the socio-cultural and economic aspect of Sangkubak, and the leaves of Sangkubak are widely used as a traditional seasoning and as an external medicinal application. This is economically, the local government of Tanah Tidung in North Kalimantan has expressed interest in developing Sangkubak as a iconic or flagship culinary product. So this is have implication on conservation aspects, because the existing of Sangkubak is the people gathering the Sangkubak from the forest. So if the local government going to develop Sangkubak as a flagship culinary product, so it's maybe impact on the conservation or the Sangkubak itself. So after the discussion with all stakeholders, next maybe, next slide please. And then one of the, we are discussed in FGD with all stakeholders is how to make the agroforestry model to Sangkubak domestication. So the Sangkubak will be going to a flagship product or iconic product of North Kalimantan, but there is no damage on the forest. So we suggest that multi-strata agroforestry is one of the model that can be developed. Next slide. This is the agroforestry model that all stakeholders agree to develop for enhancing the production of Sangkubak with multi-strata agroforestry that mimics the natural habitats of the Sangkubak itself. In the upper canopy, we can plant timber or fruit trees such durian or nothing else. And the mid strata is Sangkubak, and the lower strata is ginger, coffee, or medicinal herbs. And it's have to be well managed because requires external input, and if we are going to the model of agroforestry, we must low input, and also focusing on pruning and managing the lianas growth to prevent overcompetition with the host tree, and also to manage the harvesting periods. Next. Agroforestry cultivation is one of the models that agreed by all stakeholders. We hope that these models can make income diversification for local communities. Also, one of the community empowerment program that make provides opportunities for local farmers to become producers, not just collectors of Sengkubak. And also one of the efforts to conserve the biodiversity, because we know that also in North Kalimantan, the illegal logging or the shifting land into plantation is quite high. So the agroforestry models is one of the way to how we can conserve and also we can make economic activities there. Next. Next slide, please. Yeah, thank you. Thank you. And I think this research is still ongoing now in North Kalimantan, and the local government is very exciting to implement the agroforestry model in develop the Sengkubak plantation. Thank you.
Thank you very much, Dr. Nonon Saribanon, for giving such informative and interesting presentation. Ladies and gentlemen, let us welcome the third distinguished speaker, Dr. Vivitri Dewi Prasasti MSc, to deliver her presentation. Please join me in welcoming Dr. Vivitri Dewi Prasasti MSc with a round of applause, please. Dr. Vivitri Dewi Prasasti MSc, who will be speaking to us about grafted peptide targeting EGFR dimers for lung cancer treatment. Please allow me to read a brief biodata of Dr. Vivitri Dewi Prasasti MSc. Dr. Vivitri is a Vice Dean of Faculty of Biology and Agriculture, Universitas Nasional, and head of the Intellectual Property Rights Center at Universitas Nasional. She was a postdoctoral researcher at Louisiana State University and the University of Louisiana Monroe, where she focused on cancer biology and toxicology. Dr. Vivitri, time is yours.
Thank you, Prof. Endarti, for the time. Good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. I'd like to share one of our study in grafted peptide targeting EGFR dimers for lung cancer treatments. It's actually our work for the past 2 years. Next, please. So, as we know, lung cancer remains a devastating global health issue, and non-small cell lung cancer, or NSCLC, accounts for the vast majority of these cases. The key message here is that current treatments, while effectively initially, face significant limitations that compromise long-term patient outcomes. Long-term patient outcomes that we see that EGFR overexpressions in about 30% of NSCLC patients, and the presence of HER1, HER2, and HER2 dimers is strongly correlated with poor survival. This is a critical patient population that needs better options. Current antibody therapies require inconvenient intravenous administration, and the widely used tyrosine kinase inhibitor, or TKIs, are plagued by the rapid development of resistance. Ultimately, we lack a treatment that offers the convenience of oral dosing, that stability to withstand the body's environment, and a mechanism that bypasses TKI resistance. We must move beyond this limitation to improve patient quality of life and treatments adherence. So let's focus on the molecular mechanism that we choose to target. Next, please. The critical mechanism driving uncontrolled cancer cell growth in NSCLC is receptor dimerization. The EGFR family of receptors, including HER1, HER2, and HER3, regulates cell growth and survival, but it's the formation of heterodimers, particularly HER1, HER2, and HER2, HER3, that acts as the primary oncogenic signal in many NSCLC cases. Overexpression or mutation of these receptors leads to constant uncontrolled signaling driving the cancer. The dimerization process is the essential bottleneck for activation. By targeting the protein-protein interaction at the dimerization interface, we can block the signaling cascade right at the source. This strategy prevents the downstream oncogenic effects without disrupting the individual receptor function, offering a highly specific and effectively therapeutic window. Next, please. To address the challenge of drug delivery and stability, we turn to nature of inspiration, specifically the sunflower trypsin inhibitor, or SFTI1. Our solution is developing the SFTI1 into SFTI-G5. It's a grafted peptide that leverages the exceptional stability of the SFTI1 peptide. This natural bicyclic structure held together by a disulfide bond provides inherent resistance to enzymatic degradation. We use a rational design strategy, replacing the non-essential loops region of SFTI1 with sequences engineered to target HER2. This grafted technique maintains the scaffold conformational constraints, which is key for stability, while imparting high specificity for the HER2 extracellular domain. So SFTI-G5 binds to HER2 with high affinity, and importantly, it acts as a dual inhibitor, blocking both the HER1, HER2, and HER2, HER3 dimerization events. This innovative approach is the first to combine a natural product scaffold with rational design to create an oral bioavailability peptide targeting EGFR receptor dimers. Next, please. So in our study, we tackle a major challenge in cancer treatment, creating a drug that patient can simply swallow the pill. We focus on lung cancer, where proteins like HER2 drive tumor growth. The problem is the peptide drugs, while highly specific, typically can't survive the digestive system. Our solution was inspired by nature. We used SFTI1, a remarkably stable peptide from sunflower, as our foundation. We grafted specific sequences onto the scaffold to target HER2, creating with what we call SFTI-G5. And then we tested it in mice with HER2 positive lung tumors. Orally at 50 milligrams per kilograms, SFTI-G5 successfully suppressed tumor growth. The designed peptide proved orally bioavailable, both stable and effective. Next, please. The primary hurdle for any peptide drug, especially an oral one, is surviving the harsh environment of the gastrointestinal tract or GI tract. SFTI-G5 overcomes this challenge due to its exceptional stability, which is inherited from the SFTI1 naturally. We tested SFTI-G5 against the most aggressive digestive conditions, including simulated gastric fluid with pepsin and simulated intestinal fluid with pancreatin. The results are striking. The peptide remained completely stable with no detectable degradation after 6 hours in both environments. This remarkable stability is due to the concern by cyclic peptide and the protective disulfide bond, which shield the peptide from the protease attack. Furthermore, the peptide shows excellent stability in liver microsomes and retains 75% integrity human serum after 12 hours. The stability profile is clinically significant because it directly enables oral administrations, dramatically improving patient compliance and quality of life compared to existing intravenous antibody therapies. Next, please. So we've established SFTI-G5 remarkable stability against degradation. Now we need to know if it stays in the body long enough to work. The key message here is that SFTI-G5 exhibits an exceptionally long half-life, which is critical for a convenient oral drug. Our pharmacokinetic studies show a terminal half-life to 43 hours. This is an incredible result for a peptide, supporting a sustained therapeutic effect and allowing for a much less frequent dosing schedule. We also observe biphasic absorption after oral administration. The peptide first precipitates in the intestinal fluid, then gradually dissolves and absorbed in the bloodstream, leading to peak concentration at both 2 and 8 hours. This slow, sustained release mechanism is what helps maintain therapeutic concentration over time. The 43 hours half-life means we can achieve sustained therapeutic levels with twice weekly oral dosing at 50 milligrams per kilogram. This significantly reduces the administration burden compared to the weekly intravenous injection required for current antibodies therapy. Next, please. The critical question here is whether this favorable pharmacokinetic profile translates into real therapeutic benefit. Well, the answer is resounding yes, because we evaluated SFTI-G5's efficacy in a Calu-3 xenograft mouse model. This is another type of lung cancer, which is standard model for HER2 positive NSCLC. The core finding is that oral SFTI-G5 at 50 milligrams per kilogram achieved tumor suppression comparable to standard antibody, like pertuzumab. Specifically, the twice weekly oral dosing significantly reduced tumor volume compared to the control group. So this is a major breakthrough because we are achieving the same level of efficacy as established intravenous antibody therapies, but with a simple oral pill. Furthermore, we saw no significant body weight changes in any of the treatment groups. Next, please. So we've shown the peptide works, but we must confirm it works the way we designed it to by inhibiting dimerization. We use the proximity ligation assay, or PLA, on tumor tissue from the treated mice to visualize the dimerization events. The result definitely confirm our mechanism of action. In the control tumors, we saw abundant red fluorescence indicating active HER1, HER2, and HER2, HER3 dimers. In the SFTI-G5 treated group, this signal was significantly decreased. This proved that SFTI-G5 is successfully binding to HER2 and preventing its dimerization with both HER1 and HER3. This blockage of the oncogenic signaling pathway leads to a subsequent downregulation of both HER1 and HER2 receptor, expression in the tumor cells. So this is the precise molecular event we aim for, confirming the SFTIG5 is acting as a dimerization inhibitor, shutting down the signaling cascade as its source. Next, please. So since SFTIG5 targets HER2, we needed to confirm its specificity for HER2's positive tumors to ensure a safe tumors and targeted therapy. We tested SFTIG5 in a patient-derived xenograft model that had very low HER2 expression, simulating a HER2 negative patient population. The key takeaway is that SFTIG5 showed no significant tumor volume reduction in this low HER2 model. This negative result is actually a very positive finding. It confirms that SFTIG5 is highly specific for HER2 positive cancers and will not affect normal tissue or tumors do not overexpress the target. Next, please. So the final piece of the puzzle is positioning SFTIG5 against the current standard of care, which is primarily tyrosine kinase inhibitors or TKIs. SFTIG5 offers a significant comparative advantage by addressing the major limitation of TKIs. First, is SFTIG5 targets the dimerization interface, which is upstream of the kinase domain. This means it can potentially overcome the widespread resistance that develop against TKIs, which target the kinase domain directly. Second, SFTIG5 is highly specific for HER2 positive tumors, whereas many TKIs are pan-EGFR or HER1 inhibitors, leading to more off-target side effects like severe skin rash and diarrhea. Finally, SFTIG5 mechanism of blocking of protein-protein interaction is fundamental different from TKIs, offering a new therapeutic option for patients who have failed TKI treatments. Next, please. So we've established SFTIG5 efficacy and its targeted mechanism, but safety is paramount for any new therapeutic agent. I'm pleased to report that SFTIG5 demonstrates an excellent safety profile in our comprehensive preclinical studies. Histopathological analysis of all major organs, such as heart, kidney, lung, liver, and spleen, showed completely normal morphology. We saw absolutely no sign of cellular degradation, necrosis, or inflammatory infiltration, which are common concern with many small molecule inhibitors. Furthermore, serum biomarker analysis confirmed these findings. So key indicators for liver function such as ALT and ALP, and for kidney function such as blood urea nitrogen or BUN and creatinine, all remain within the normal physiological range throughout the treatment period. Next, please. So the data we presented today position SFTIG5 as truly novel therapeutic paradigm for HER2 positive NSCLC. This research successfully translates a natural product scaffold into an orally bioavailable drug that targets a critical protein-protein interaction in cancer. So the key innovation here are transformative for peptide therapeutics. We have the first oral peptide targeting EGFR or HER1 dimers, overcoming the major limitation of poor stability that has plagued this drug class for decades. This nature-inspired design utilizes the SFTI1 scaffold, aligns perfectly with sustainable drug development. Next, please. So this complex and exciting research was truly a collaborative effort. I would like to express my gratitude to our team, Dr. Siturama, Prajasreta, Sitanshu, Achut, Debajoti, and so on, for collaborative research together, and also the supporting institutions such as ULM, LSU, Mayo Clinics, and Universitas Nasional. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Fifitri, for giving such informative and interesting presentation. Thank you for all distinguished speakers. Now we come to discussion, question, and answer. But the committee just warned me about the time, so it is only allowed 2 questions. So, is there any question for the left side? No? Oh, the right side. Okay. Can you give the microphone to, please? Okay. So please mention the name, institution, and which distinguished speaker the question is addressed.
Hello? Okay. Thank you for the chance. Hello, my name is Aditya Rahma Badri. I'm a master student in biology at the Universitas Nasional.
Okay.
And my question now is for Professor Papi. What a lovely name.
For P.
Yes.
Oh, I hope she is still on the Zoom, right? Okay.
I hope so.
Okay.
Okay. So for Professor Papi, I'd like to ask about phytochemicals compounds identified in Vernonia amygdalina. Are those compounds unique to this species only, or are they also present in other Asteraceae species? A similar anti-colon cancer potential.
Thank you. I hope.
Is it understandable?
Yeah, I hope Professor Poppy can hear the question completely.
You.
I'm sorry. Dr. Hafiz is on the Zoom right now. Yeah, maybe you can deliver it, the question on the Zoom, right? So the professor can answer it, the question. Okay? I'm sorry. Is there any question for the distinguished speaker here? Oh, okay.
Thank you very much. I have a question regarding the study on the STF1 for Dr. Fifit.
Okay.
It's a nice study where there is showing that there has nice stability. I was wondering, like, they have the data that it was given orally and they show good plasma profile. Is there any study suggesting what mechanism of transport for this peptide across the gastrointestinal barrier? Yeah.
Okay, thank you for the question, Dr. Marlin. I'd like to try to answer the question about the other mechanism that can be analyzed through the gastrointestinal tract, something like that. We have several data, but so far that we expose or we can provide the data is all about the stability through the organ and the gastric intestine. So, but we were still working on the other kind of mechanism. So yeah, in the future, probably we can report the data regarding that mechanism. I'm sorry, I cannot answer that right now, but we have the data regarding the analysis for the intestinal analysis that we have so far in this
presentation.
I hope you're satisfied with the answer, right? Okay, is there any question? One question more? Okay.
Hello? Okay. Hi, my question is for, of course, the umami and savory plant person, Dr. Sari Banan. I was just curious as to this plant, is it commonly consumed here and is it available in the marketplace?
Nowadays, it's only in traditional market. In every traditional market in Kalimantan, I think the people say the sengkubak leaves.
Okay, thank you. I'll probably follow up with you and very curious about it and would like to taste for myself if I can. Thank you.
But the local government of North Kalimantan is very eager to make this product as a iconic product to like an alternative for flavoring enhancer.
Okay. Well, I think the question is enough. Ladies and gentlemen, we finally come to the end of the session. Before I close the session, I would like to take the conclusion from what we distinguished speakers have presented. I think this session is reached a part of this goal of the international seminar because we have heard that many plants have really promising candidate for treating this disease, right? Chronic disease. So I think because it's very valuable plant, so we have to care for plant, we have to love for plant because plant is many benefit for us, right? So give applause to all distinguished speakers and for you all. Thank you.
Thank you to our moderator and also invited speakers. The next session is a present token of appreciation to our invited speakers and moderator. We kindly invite Professor Dr. Ernawati Sinaga, MS-APT, to come forward to the stage. And the token will be given to Dr. Insinyur Nonon Saribanon, MSc, and also Dr. Vivitri Dewi Prasasti, MSc. Please come up to the stage. The first token of appreciation will be given to Dr. Insinyur Nonon Saribanon, MSc from Universitas Nasional Indonesia. And the next one, the token will be given to Dr. Vivitri Dewi Prasasti, MSc from Universitas Nasional Indonesia. Thank you. Please give a big round of applause to our invited speakers, Dr. Insinyur Nonon Saribanon, MSc, Dr. Vivitri Dewi Prasasti, MSc, and also Professor Dr. Poppy Angelisa Zaitun Hasibuan, SSI, MSc, APT from Universitas Sumatera Utara, Indonesia. Who joining us today by Zoom meeting. Thank you very much. distinguished speakers, ladies and gentlemen, we have now reached the end of our plenary session. On behalf of the organizing committee, we would like to express our sincere appreciation to all keynote speakers, invited speakers, and participants for the insightful discussion and meaningful contributions shared in this plenary stage. We will now proceed to the parallel sessions, where deeper discussions and thematic presentation will take place. Each participant is kindly requested to join the room according to their selected topic or presentation schedule. The parallel session will be held in the 5 break rooms. Topic 1 in auditorium room, topic 2 in exhibition room, topic 3 in meeting cyber room, topic 4 in cyber room 1, and topic 5 in cyber room 2. You may now proceed to your respective rooms. We wish you a productive and inspiring parallel session. Thank you. To all the participants, please proceed to your respective rooms. Topic 1, exploration of medicinal plants in auditorium room. Moderator Dr. Nurse Dayan Kisni, MNS CCA. Topic 2, natural products based medicines. In exhibition room, moderator Astri Rozana Siregar MSI. Topic 3, traditional medicine. In meeting cyber room, moderator Fernanda Kairunisa MSI. Topic 4, in cyber room 1, about conservation of natural resources, moderator Astri Zulfa MSI. And topic 5, about health and well-being in sustainable development goals. In cyber room 2, moderator Sylvia Hasan MSI.
Excuse me. Yeah. Okay. Assalamualaikum warahmatullahi wabarakatuh. For those who are calling, the name is Ibu Aris Widiati. Ibu Aris Widiati, are you in this room? Ibu Aris Widiati. Not yet. Okay. Shreya Jukaria. Is she in this room? Shreya? Not yet. Mr. Handi Mahmudah Putra. Okay, thank you. Fatwa Cecilia Humaira. Okay, thank you. And the last, Dr. Tengku Laila Kamalia. Okay. I think we can start now. Ibu MC. Okay, now we move to the plenary session. Like a presentation from the participant. Before we starting the presentation, I'd like to explain in brief regarding the rules of the presentation. The presentation will be divided into 2 sessions, and then there will be 3 presenters in the first session, and the rest in the second session. Every participant should present within 8 minutes and follow it by Q&A in 2 minutes, and we will call the participant in turn. Now, let's start to the presentation. The first presenter will be delivered by Fatwa Cecilia Humaira Al-Jufri. Please come forward. She will present about preventive effect of Patikan Kebo leaves extract Euphorbia hirta-L on reducing MDA levels in rats exposed to cigarette smoke. To Fatwa Cecilia, please come forward. You can sit here, accompany me. And the next presenter to Handi Mahmudah Putra. Handi Mahmudah Putra will present about the effect of the combination of ethanolic extract Momordica carantia and Citrus aurantifolia juice on a streptozotokin-induced diabetic rat model. Okay, please join with us. And the last presenter in the first session, please come to Dr. Tengku Laila Kamalia, SPM Agriculture Science. She will present about the enhancing turmeric growth of 2 turmeric types through rhizome soaking, the efficacy of algal POC and humic acid. Okay, as I mentioned before, each participant will present in 8 minutes and then followed by Q&A in 2 minutes. Please, to Fatwa Cecilia, time is yours. You can stand up in podium.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, my name is Fatwa Cecilia. In this session, I want to presentation my research and the title.
Slide for Mrs. Fatwa Cecilia. Please share the slide from Fatwa Cecilia. Operator, please help us to share slide from This is your slide? Okay.
Yes. The preventive effect of extract Patikan ke bawah Euphorbia hirta L on MDA levels in rat exposure to cigarette smoke. Next slide. Cigarette smoke exposure remains a major global health issue, especially for passive smoker. Indonesia ranks third global is Bulgaria and Chile, according to Tobacco Atlas survey, who state 7 million annual deaths are due to total exposure to cigarette, including 1.6 million non-smoker exposure to cigarette cigarette smoke contains more than 5,000 in nicotine, tobacco specific nanocinamide, polycylic acid, and hydrocarbon. Next slide. Meanwhile, euphorbia, one of the key impact of cigarette smoke is oxidative stress in the level of MDA, a sign of peroxidation lipid. And meanwhile, euphorbia hirta is known to contain antioxidant compound. Therefore, future research is needed regarding the effectiveness of Patikan ke bawah leaf in reduction MDA in rat exposure to cigarette smoke. Next slide. This research consists of 4 main stages: extraction of Patikan ke bawah leaf, phytochemical screening, treatment of experimental blood sampling and MDA level, and data analysis prism. Next slide. First, Patikan ke bawah leaves were extracted using maceration with 70% ethanol from 339 grams of red powder. We option 38 grams of thick. Next slide. With a yield of 11.20%. Next slide. Second, phytochemical screening confirmed positive the flavonoid, saponin, tannin, steroid, terpenoid, and alkaloid. Next slide. Third, 25 male Worcester rats were divided into 5 groups: control, negative control, exposure to cigarette smoke, and treatment group receiving 100, 200, and 300 milligram per kilogram of extract. All groups were treated for 21 days. Next slide. Fourth, on day 22, blood was collected, processed using the TBA method, and MDA level were analyzed using UV spectrophotometry at 522 nm. Next slide. The result is negative control, which received cigarette smoke without treatment had the highest MDA level at 1.73, 0.51 nmol per milli. The most significant finding was that the treatment 1 group receiving 100 milligram per kilogram showed the lowest MDA level, namely 0.90, 0.22 nmol per milli, and the reduction was statistically significant with p-value. Meanwhile, treatment 2 and treatment 3 show moderate reduction, but they were not significantly different from the control group. This result indicates that the lowest dose provided the greatest protective effect. Next slide. The effectiveness of the lowest dose may explained by the concept of hormesis. This concept suggests the antioxidant work optimally at low dose, but higher dose may lead to saturation or even pro-oxidant effect. This pattern is consistent with previous studies such as SIA, which MDA level using Euphorbia hirta, and RAW, which found that low-dose resveratrol was more effective than high-dose treatment. Next slide. Thus, the strong reduction in MDA at 100 mg per kilogram suggests that this is the optimal dose before the antioxidant effect declines. Next slide. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the nice presentation. Please come back to your seat. Now we move to the second presenters, to Mrs. Handi Mahmuda. Time is yours.
Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Yes, thank you for the moderator for giving me the opportunity. I'm standing here to explain my research by the title, The Effect of the Combination of Ethanolic Extract Momorrhagia carantia and Citrus aurantifolia Juice on a Streptozotine-Induced Diabetes Rat Model. Next. The background. The diabetes mellitus is a disease characterized by high blood sugar level, hyperglycemia, as well as disturbance in the metabolic of carbohydrate, fats, and protein. Diabetes mellitus occurs because the body lacks insulin or the excess insulin cannot function in the body. According to the 11th edition of the IDF diabetes, the prevalence of diabetes worldwide continues to experience worrying increase. In 2024, it is estimated that there are approximately 5,089 million adults, 11.1%, living with diabetes. So, without effective prevention and management effort, this number could reach around 643 million by 2030. And is projected to continue increasing to reach 853 million people by 2050. Next. People with diabetes often experience a decline in physical ability and discomfort, making them the first to stress. This can cause an increase in ROS level in the body. Next. Therapy that can be done to manage diabetes mellitus. The first, conventional medicine has maximum side effect that worse the disease. Example, the glibenclamide. So the traditional medicine has minimal side effects, Momorrhagia carantia, ethanol extract, and Citrus aurantifolia. Next. So why I use this traditional medicine by Momorrhagia carantia? Because the bitter melon contains flavonoid, saponin, and alkaloid that are believed to stimulate the cell in the pancreas to increase insulin production. The bitter melon plant contains carotene and polypeptide, is similar to insulin in the body. So the citrus aurantifolia lame the antioxidant enzyme activities that play a significant role in protecting the pancreas. Next. Next to research method, this research used the extraction method. So extraction with 96% ethanol using the maceration method, let it sit for 24 hours. So separate the liquid extract from the sediment and ethanol 2 times. So the liquid extract abated is evaporated using a rotary evaporator. So further contrasted using a water bath until a thick extract is obtained. So the last phytochemical screening was tested out. Next. Administration to those to experimental animal using 6 treatment. The first, normal control, this animal to give an ACMC only. So the positive control administration of inductor streptozotocin along with anti-diabetes drug such as glibenclamide. So negative control administration of inducer streptozotocin. So the next dosage level of administration of a combination of Momordica carantia ethanol extract and Citrus aurantifolia with a ratio of 0.25 gram upon 10 gram. In the before doses, the combination from the traditional medicine use the same, but the dosing is different with a ratio 0.5 gram upon 9.75 gram. So the last doses with a ratio 0.125 gram upon 10.125 gram. Next. The acclimatization for 3 days, then blood sugar level with measured day 0 before being administered streptozotocin 35 milligram per kilogram with the intraperitoneal. So the measurement of blood sugar level in red was conduction at 3 and 5 days after the administration of the preparation. So administration of combination preparation of Momordica carantia fruit ethanol extract and Citrus aurantifolia for 7 days. Next. The data on the crates in both glucosa level were tested for normality using the Shapiro-Wilk test. If the data were normal, distribution less than 0.05, food analysis was performed used parametric test, namely two-way ANOVA by the post hoc 2K method. Next. The phytochemical screening result test in the study were conducted in the form of tests for alkaloid, flavonoid, saponin, and tannin. The first phytochemical screening, the screening from Momordica carantia, the alkaloid test was declared positive due to the presence of the white with Maillard reagent and orange color with the Dragendorf reagent. So the flavonoid test is considered positive to the presence of red, yellow, or orange solution. So the saponin test declared positive because the form did not dispense for less 10 minutes. So the tannin test is positive due to the presence of both black or green solution. So the phytochemical screening from Citrus aurantia, the same the phytochemical screening traditional medicine just same but the aurantia Citrus aurantia folia. Next. The saponin was declared negative because no present form from the last 10 minutes. The tannin test is positive, thus 2% of bulbous black or green solution. So the combination preparation are the alkaloid to be positive because is there the orange color with dragon dove reagent, the flavonoid, there is the red, yellow, and orange solution. Next. So the saponin, the positive because the form for it did not disperse for less than 10 minutes, and tannin positive because the both black green solution. The following table show the blood sugar level of red. The table above show the average for a group. In the above group, this is a treatment 185 point to 25 milligram per dl. Has better effective compared to the other preparation group. So from the previous table, the following graph was, next slide, next,
Excuse me, your time is 2 minutes left.
From the previous table, the following graph, the show change in the blood sugar, the fourth time 0, blood sugar level just 1 to 3 days and 10 days. Next. And the last, the consultation, the combination of ethanol extract of Momordica carantia and citrus affect the reduction of blood sugar level in the diabetes rate. The combination that produces the best effect in treatment 3, which is the administration of 0.125 gram of bitter melon extract plus the 10.125 gram of lime. Next. Yes, until here I explain my research. Thanks. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the nice presentation. The last present will be delivered by Dr. Tengku Laila Kamalia. For Dr. Tengku Laila, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Thank you for the opportunity to me to representative our research. This is our research team, me, Tengku Laila Kamalia with Chinese Bar and Mirna Nur Imania. Our research is a preliminary study on turmeric. So we will present, introduce turmeric or curcuma longa and curcuma zedoaria is a globally valued crop used both as spice and international medicine. Its economic and medicinal importance continues to grow, driving demand for higher yield and quality. One major constraint in turmeric production is low rhizome productivity, often linked to poor rhizome sprouting and vegetative growth. Conventional cultivation methods sometimes rely on synthetic inputs, which can be costly and environmentally unsustainable. There is increasing interest in using organic biostimulant to enhance crop growth and reduce chemical dependency. Humic acid and algal-based in liquid organic fertilizer, or POC, are not well established for nutrition for root development. Next slide. And while both substances show promise, comparative studies on their efficacy via rhizome soaking are limited. Additionally, responses may vary between turmeric types, yellow and white turmeric, which has not been extensively studied. This research aims to evaluate the effect of rhizome soaking in humic acid and algal POC on the vegetative growth of two turmeric types, compare their effectiveness in improving parameters such as fresh weight, shoot number, and leaf development. The significance of this study provides scientific evidence on the use of locally available organic inputs and support sustainable turmeric production and the potential for higher productivity and for environmental impact. Next. Next. Okay. Our research was done at Bambu Kuning Greenhouse, Faculty of Biology and Agriculture, Universitas Nasional, Jakarta, Indonesia. It was conducted from September 2024 until January 2025. And we use factorial RCBD with two factors. First factor is kind of turmeric, yellow turmeric and white turmeric. And the second factor is humic acid solution, liquid organic fertilizer from alga, and control with only the water. Each treatment combination was replicated 3 times, and each unit it consists for 3 polybag. Next. Material and methods. Every rhizome growing in sterilized mix of topsoil, compost, and sand in 2:1:1 ratio. In polybags at size 20 centimeter and 20 centimeter. The temperature are average 24 and 4 derajat Celsius. Relative humidity is 70 and 10%. And for water daily to maintain field capacity. For this presentation, we only showed the data about at 4 months after treatment, while the data in every week we didn't show in this presentation. And data analysis using two-way analysis of variance at 5% significance level. If a significant effect was found, it was followed by LSD test at 5% level to compare treatment means. Next. So this is our result from this preliminary study. So we can see that for fresh rhizome weight, there is not insignificant interaction, and for 5 other parameters, the interaction was significant. Next. This is for fresh rhizome weight. The POC alga soaking media had the greatest effect and was significantly different from the control. Next. This is for fresh leaf weight. So we can see the table for interaction. So we can see that for yellow turmeric and also for white turmeric, VOC alga is the best. And we can see the graphic for interaction. The red is for yellow turmeric and the green for white turmeric. Next. This is for total fresh weight parameter, and this parameter we can also see that the best treatment for yellow turmeric is POC alga, And for white turmeric is also POC alga, and that the graphic for interaction, soaking, and total fresh weight. Next. Okay, this is analysis of the interaction of number of soot variable between different types of turmeric. And we can also see there that the best treatment also POC alga for yellow turmeric and white turmeric. Next. This is for number of soot baths. In yellow turmeric, we can see that the best treatment is soaking in humic acid, while in white turmeric, we can see the high number of soot baths is controlled, but it's not significant with alga and humic acid. Next. And this is number of leaves for yellow turmeric and white turmeric. And we can see also there, POC alga is the best treatment. Next. We can see that alga POC consistently yielded the highest fresh weight for rhizome, leaf total fresh weight for both turmeric types. And seaweed-derived biostimulants like algal POC are rich in macro and micronutrients, amino acid, and plant growth regulator like cytokinin-like compounds and betaines. This component enhance nitrogen metabolism, chlorophyll synthesis, and overall plant vigor, leading to greater biomass production. So the implication, rhizome soaking with alga POC provides early excess growth priming, making it an effective organic strategy to boost productivity. Next. And we can see white turmeric excel in rhizome and total biomass, while yellow turmeric produce more soots and soot baths. The interaction between variety and treatment was significant for most parameters. The efficacy of biostimulant is highly genotype dependent. Genetic variation in nutrient uptake efficiency, hormone sensitivity, and sourcing partitioning explain differences response. And the implication, one-size-fits-all approach is insufficient. Recommendations should be variety specific. So POC alga for white turmeric, especially for biomass yield, and humic acid for yellow turmeric for propagation material. Next. Humic acid was particularly effective for yellow turmeric in increasing soot and soot bath numbers, though less so far biomass. Humic substance act as biostimulant and soil conditioner. They improve root architecture and membrane permeability, facilitating nutrient uptake. Their hormonal activity can specifically stimulate cell division and bud break. And the implication, humic acid is valuable for improving plant establishment and vegetative propagation, potentially through mechanism different from direct nutrient algal POC. Next. And both organic treatments outperform the control, demonstrating the potential of local organic resource. Integrating biostimulant into crop management is a core strategy for sustainable intensification. They can improve nutrient use efficiency, reduce mineral fertilizer requirements, and enhance crop resilience. And this study provides a practical model for using locally sourced algal POC and humic acid to support productive and environmentally sustainable spice for the system. Next. So the conclusion, algal POC is the most effective treatment, significantly boosting fresh weight for both turmeric types, and growth response is genotype specific. White turmeric excel in biomass, while yellow turmeric produce more soot and buds. And humic acid is a valuable biostimulant, particularly effective for enhancing shoot development in yellow turmeric. Rhizome soaking with these organic inputs present a viable, sustainable practice to improve yield and reduce synthetic input dependency. So practical recommendation for high rhizome yield, use alga POC, and for better propagation material, we can use humic acid, especially for yellow turmeric. Next. Okay, thank you very much for Universitas Nasional, which funding this research. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for all the presenters. Now we open question from audience in this room. Is there a question for our presenters? From our side, left side, is there any question? From our right side, is there a question for our presenter? No question? Okay, if there is no question, I think we are in the end of this session. We will move to the next session. Thank you very much for all the presenters. Please give big applause for our presenters. Thank you very much. Okay, now we move to the next session. In the second session, we have two presenters that will present their article or their paper. We will invite Ibu Aris Widayati. Is she here? Yeah, Ibu Aris Widayati. She will present about does herbal use correlate with adherence and therapy outcome, a cross-sectional study among Indonesian asthma patients. And the second presenter is Miss Sheria Jukaria. Please come forward also with Ibu Aris. Miss Sheria will present about chemical composition of the essential oil from Myrica esculenta. Please sit. Bajhem XD Dawn leaves collected from Kampawat, Uttarakhand, and influence of environmental condition on chemical composition. Well, same with the previous session, you have within 8 minutes to present your article, and then followed by Q&A. Okay. So the first presenter, please Ibu Aris present your article. Yeah, thank you.
Good morning, everyone. I would like to present my study entitled Does Herbal Use Correlate with Adherence and Therapy Outcome? This is a cross-sectional study among Indonesian asthma patients. And I'm Aris Widayati. I'm from Universitas Muhammadiyah Jakarta. And the research team are Dr. Ingadida Hatning, and then Dr. Irna Tri Wulandari, and then Ms. Hana Rashidah Umar Ganis. Please, next. Yes. As we know that asthma is a chronic disease and requires long-term management, and many studies already showed that herbs influences the adherence to medication. On the other hand, the use of natural medicines can be a complementary therapy for asthma patients in managing relapse episodes. So the objective of the study are to explore the use of natural remedies among asthma patients, and then to determine the relationship between its uses and adherence to medication, and also the therapeutic outcomes. And the method, this is a cross-sectional study conducted in Jakarta City, and then the respondents were asthma patients attending public and private health facilities in Yogyakarta, and they were selected purposefully. And then to assess the therapeutic outcome, we used the asthma control test questionnaire, which has been validated. And then from the data on the adherence to medication, we used the MARS questionnaire, which also has been validated. And then the data were analyzed using Mann-Whitney test and also the chi-square test. And p-value less than 0.05 was considered as significant. And the results, we have 99 respondents, and then from those who used the herbals for their asthma medication is actually only small. It is about less than 20%, about 18%. And then the kind of herbal used, mostly raw and fresh medicinal plants. It is about 66%, and also they use jamu that they obtain from the traditional markets, and also they use natural products made by manufacturer. It is about 13%. And from the statistical analysis, there is no significant difference in the adherence to medication between user and non-users of natural medicine. And also, there is no significant difference between user and non-user in terms of health-related outcome. And the source of information, I'm sorry, can back, yes. The source of information, mostly from family, friends, and also relatives. And also they obtain information from health professional, and of course from internet, and also by their experience. And from the conclusion, please, next slide, yes. These natural findings contribute to evidence supporting caution acceptance of traditional medicine as agents in asthma management, and also natural products may be safely integrated, but monitoring remains essential to avoid undetected substitution effect seen elsewhere. And also from the future study, we are aware that this is a very small sample, so the larger studies with diverse population is required to generalize and assess long-term outcomes like lung function. And this is my presentation. Thank you for listening.
Thank you very much for Ibu Ariswadayati. Please be seated. Now we move to the Shreya presentation. Please come to podium.
Good afternoon, respected professors, researchers, and my colleagues. Myself, Shreya Jukaria from Kumaon University, Nainital, India. Today I am here to present my research work on the topic chemical composition of the essential oil from Myrica esculenta, bush hemp, XD dawn leaves collected from Champawat, Uttarakhand, and influence of environmental conditions in chemical composition. Please next. The content of my presentation is first introduction, material and method, research and discussion, significance of the study, conclusion, followed by future directions, references and acknowledgement. Firstly, moving to the introduction to Myrica esculenta bush hemp, commonly known as box, miracle or blaeberry or kafal, medium-sized evergreen tree belonging to the family Myricaceae, native to the sub-Himalayan belt, spacing India, Nepal, and Bhutan. Moving to the next slide, please. Next, please. This is the scientific classification of Myrica esculenta. The kingdom is the Plantae, class is Magnoliopida, and family Myricaceae. Next, please. These are the vernacular names of Myrica esculenta. Commonly, it is known as kafal in Hindi, and Latin name is Myrica esculenta. In English, it is known as box, myrtle, or bayberry. Next, please. The botanical description of Myrica esculenta. First, stem and bark. These are erect, woody trunch reaching 30 centimeter diameter with grayish-brown fissured bark releasing aromatic resin. The good advantage of this plant is its bark as well as its leaf and its fruit. All the things are used as aromatic. So the description of leaves, it is simple, alternative, lanceolate leaves with serrated margins. Now moving towards flower, dioecious species with inconspicuous flowers. Male catkins are yellowish in color. Female flowers are shorter with spikes. Next, please. Now the cultivation practices, mostly it is propagated and it takes up to 6 to 8 years to get matured. And the soil requirements is it prefers drained, loamy to sandy loam soil rich in organic matters. The pH should be from 5.5 to 6.5. And the growth timeline, as I told, it takes 6 to 8 years to mature. Harvest season is basically May to June. Next, please. And Uttarakhand is the major contributor of kafal. Now moving towards the nutritional and phytochemical profile. First, it is rich in bioactive compounds such as flavonoids, tannins and phenols, terpenoids, diaryl haptenoids and glycosides, and essential oil. These all things are the rich in bioactive compounds as they show anti-estrogen properties, antimicrobial, anti-inflammatory, and so on. Next, we come to the nutritional, previous please. Nutritional content. It is rich in carbohydrate, protein, dietary fibers. It contains some minerals such as sodium, potassium, calcium, manganese, iron, copper, zinc. It is rich in vitamin C content, polyphenols, and antioxidant. Next, please. These are the pharmacological properties and traditional uses. As it is used as an antimicrobial, it shows good antimicrobial activity, so we can use it as an antimicrobial agent. Antioxidant and anti-inflammatory activities are also shown. Gastrointestinal relief, it is very much used. Its fruit is used for curing the gastrointestinal diseases, and it also shows hepatoprotective and anti-diabetic effects. Next, please. Now, this is the contemporary application and the research gap. Value-added project. We, majorly in India, many such value-added products are made from this kafal as jellies, pickles, syrups, fermented drinks, and essential oil is used in Ayurvedic formulations, herbal teas, and tropical preparations. Now, next is the nanotechnological application. Recent studies demonstrate the extract-based albumin anti-cancer nanoparticles are used in anti-cancer potential with strong cytotoxic effects against MIA-PACA2 cells. And the research limitations, most studies focus only on bark and fruits, but the significant gap was existing in leaf essential oil characterization using advanced analytical techniques like GC and GCMS. That was the main reason of mine to take this plant for my research. Next, please.
These are the material and method how I perform my experiment. Firstly, I collected and identified the Myrica esculenta. It was collected from Naryalgaon district, Champawat, Uttarakhand, India during the month of April 2025. Botanical identification was done at my college, Botany Department, Kumaon University, Nainital. Next, please. This was the leaves collected by me, which was undergo to the process of hydrodistillation, and the essential oil was extracted from these leaves. Next, please. These were the analysis. After the essential oil was collected, it was processed through an analytical technique called GCMS, gas chromatography and mass spectrometry. So these were the conditions I used during my GC characterization. Next, please. This was the oil yield. As the smell is very less, so the yield is also very less, 0.01 volume by weight. And the oil was yellow in color along with a strong aroma. Next, please. This is the chromatogram of my Myrica esculenta leaf oil, GCMS. Total compounds were identified 48, and the oil accounted for by identified compounds were 90.5%. E-carophyllene was the major component, which came in 40.46%. Next, please. These are all the compounds that were identified in the essential oil. Next, please. These are the 10 top major components. First is E-carophyllene, 40.46%, carophyllene oxide 8.83, zerenyl acetone 4.15, phytol 2.64, delta cadmium 2.60, gamma murolin 2.51, alpha amorphine 1.72, spatunolol 1.57, beta copain 1.46, guaia 6,9 diene 1.16. Now moving ahead to the next, please. These are the uses of major component. As I earlier showed the major components, these are their uses. As E-carophyllene, which is the major component, it shows good anti-inflammatory and antimicrobial properties. Second was carophyllene oxide, it shows antifungal and antioxidant uses. As shown, zerenyl acetone is aromatic and it shows skin smoothing effects. Next, please. This is a comparative analysis. This bark work was done by Agnihotri et al. At 2012. I have taken it from literature review and compared it with my work, as my work contains E-carophyllene as the major component, but this work contains N-hexadecanol as the major component, which was the oil of bark. I have taken the oil of leaves, and this work contains the oil of bark. Next, please. This is the significance of a study. Firstly, chemical profiling. I collected and it undergo on the chemical profiling, then research gap. Bioactive compounds were 48. Potential applications were, this has major use in pharmaceutical, aromatic and antimicrobial product developments. Its sustainable use supports sustainable use and value addition of an important Himalayan medicinal plant. Next, please. This is the conclusion of my entire work. 48 compounds were identified from the essential oil of dried Myrica esculenta leaves, showing rich chemical biodiversity. Major components were E-carophyllene, carophyllene oxide and zerenyl oxide. Oil composition dominated by sesquiterpenes and oxygenated terpenoids, reflecting strong medicinal and aromatic characteristics. Next, please. Next, please. These are the references of my entire work. I took the help from these 4 journals. Next, please. Now, the acknowledgement. I
express my sincere gratitude towards Professor Chitra Pandey, Dean Faculty of Science and Head Department of Chemistry, DSB Campus, Nainital, for providing the necessary laboratory facilities, and to Professor Geeta Tiwari, my supervisor, DSB Campus, Nainital, for continuous support and guidance. ANRF Pair Project for financial support. I would like to extend my thanks to my seniors, Ms. Abha, Ms. Manisha Joshi, and Aisha Siddiqui for their help. Thank you.
Thank you very much. Okay, now we open a question for the next session. Is there any question from our left side? Is there any question? No question? Yeah. Committee, please help us to give the microphone.
Thank you for the time. I want to ask to Sakria, is it the fruit can produce oil too or not? And what about the fruit can be eat or not? Because I see that the oil is from only leaf, not from fruit.
Ma'am, my work is on leaves, but the fruit is also used for eating too, and its oil is also extracted for some further literature. The fruit is eaten. It's used for eating and it is good for stomach as gastrointestinal diseases. It is used in curing the stomach problems, and it is a basically native fruit.
Okay, thank you.
Thank you.
Thank you. I hope you satisfied from her answer. Is there any question again? Yeah.
My question to Shreya. You have identified so many components from the leaves, and in research gap you mentioned about like in stem it has been explored, but in leaf it has not been explored. So based on your finding on the phytoconstituents or maybe essential oils, what activity can be planned?
Activity in which sense?
In leaf, your 48 compound something you told.
Yes, yes.
And,
So activity can be done on the basis of major component. As I mentioned that it has E-carophylline in the major. So
Okay.
it shows anti-inflammatory activity. So we can do anti-inflammatory activity on it, antioxidant activity on it.
antimicrobial?
Yes, it can be done.
Okay, thank you.
Okay, thank you.
Thank you. Now the last, any question again? Enough, yeah, I think. Okay. Once again, please give applause for our speakers. Now we are in the end of this session. Okay, thank you. Okay, I hope we have a new insight from all the presenters today regarding the exploration of medicinal plants that bring to advance global health and sustainability. Once again, thank you for all the presenters and all participants who joined on this event today. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon.
And for the method, this review follow PRISMA 2020 guideline and was registered in Prospero and ensure transparency. We perform a comprehensive search across multiple databases covering study from 2060 to 2025. So study selection process is first search, so to screen eligibility, full text, and analyze. And this is inclusion criteria and exclusion criteria. In inclusion criteria on study type, experimental, in vitro, in vivo, and RCT, year range in 2015 until 2025, 10 years window, and species is Pandanus tectorius, language English and Indonesia, full text is available and extractable data. This is the PICO, population intervention, comparison, and outcome of this research. The study population is language published between January until November, and only full text publication with extractable quantitative data were included. This is a study selection. And this is a PRISMA flow chart from identification, screening, and then study include in review is 25, and report of include study is 27. And this is for the result. For antioxidant, we find a key finding DPPH radical scaffolding IC50 is 12.3 until 45.6, and ABTS radical scaffolding IC50 is 8.5 until 38.2. Mean IC15 values is strong. It's a comparable efficacy to vitamin C with the IC50 6 to 50. So and this is subgroup analysis show fruit extract has superior immunomodulatory activity, and 80% ethanol was the most effective extraction solvent, maximizing phenolic and terpenoid recovery. And aqueous extract demonstrate lower efficacy due to the limit solubility of key compound. And this is molecular mechanism. Mechanism pathway include immune activation, antioxidant effect, neuroprotection, and lipid lowering. And the clinical implication, product development, translation opportunities include immunonutritional supplement, lipid management nutraceutical, anti-inflammatory topical, neuroprotective formulation. And this is a future research direction. Several research gap remain phytochemical standardization, bioavailability pharmacokinetic, mechanistic pathway elucidation, mammalia in vivo study, combination therapy, formulation option, so conservation strategies to ensure sustainable clinical trials and long-term safety. Okay, we jump to the conclusion. Okay, for the conclusion, Pandanus tectorius demonstrate robust immunomodulatory, antioxidant, anti-inflammatory, lipid lowering, and neuroprotective effect. Fruit extract and 80 ethanol extraction provide the most consistent bioactivity. And this is a systematic review highlight the strong potential of Pandanus tectorius for the future nutraceutical, therapeutic, and function food development. Thank you very much for your attention. I welcome for any question or discussion. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for your presentation, Miss Aina. Is there any question from Zoom?
I want to ask the question to Ms. Aina.
Okay, the time is yours, Miss Reza.
Thank you for the interesting presentation, Mrs. Aina. I have one question. How do you propose addressing sustainability concern related to increased use and harvesting of Pandanus tectorius? Yeah.
Yes. Okay, Ms. Reza Pertiwi, thank you for the question. Pandanus tectorius can remain sustainable by using controlled cultivation and selective harvesting by protecting its natural habitat. In Bengkulu, this plant is very abundant and not widely used, so I believe its availability will remain high for the maybe next 5 or 10 years.
Thank you, your answer, Ms. Aina. Thank you, Ms. Fernanda.
Okay, thank you, Miss Reza, for your question and good answer for Miss Aina. Okay, maybe we move to the next presenter. It is from Miss Bara Nurul Zahira. Is there Miss Bara Nurul Zahira in here? Okay, Miss. Yeah.
Hello.
Yeah, Miss.
Okay, I will present my.
Can you present your own presentation? Yeah. Okay, thank you very much. Are you ready for your presentation?
Yeah.
Okay, the time is yours.
Good afternoon, everyone. I'm delighted to be here today, and I appreciate the opportunity to present my research to such a distinguished audience of scholars and professionals. My name is Bara Nurul Zahira, and I'm a graduate student at Universitas Jenderal Sudirman. And today I will be discussing my research on the effect of vacuum fractional distillation on the antibacterial activity of nutmeg myristica fragrans essential oil against common pathogens. And during this presentation, I will organize my findings into 4 distinct sections. First, I will provide an introduction that outlines the objective of my research, and next I will discuss the methods, offering a brief overview of the apparatus, ingredients, and techniques that I employed in my study. Following that, I will delve into the results. And finally, I will conclude with a summary of the key findings of my research. Okay, as we are all aware, antimicrobial resistance is a significant threat to global health. Therefore, the search for effective and sustainable antibacterial agents is critical. Our focus on nutmeg essential oil is due to its historical use in traditional medicine and its diverse pharmacological properties, particularly antimicrobial activity. Nutmeg essential oil derived from Myristica fragrans contains bioactive compounds like myristicin, elemicin, and saffron. These components contribute to its antimicrobial activity, to its antimicrobial properties. Effective essential oils are increasingly recognized for their potential against drug-resistant microbes. So, vacuum fractional distillation is critical technique we employ to separate the components of nutmeg essential oil by utilizing reduced pressure. We effectively exploit the varying volatilities of these components, which also helps protect heat-sensitive molecules during the process. As noted by Nam et al. In 2016, to assess the antibacterial potential of the oil and its fraction, we employ the agar-well diffusion method. This method allows us to quantitatively compare the inhibition zone produced by both the crude nutmeg oil and the purified fractions. We focus on several test microorganisms, specifically gram-negative bacteria, including Escherichia coli and Pseudomonas aeruginosa, as well as gram-positive bacteria, Staphylococcus aureus, and Propionibacterium acnes. Our objective was to enhance the antibacterial activity of nutmeg essential oil through the application of vacuum fractional distillation, which allows us to isolate active components while preserving their efficacy. So the tools we used included Baker's flask, a hot plate stirrer, a GCMS for analysis, and a vacuum fractional distillation apparatus. And the ingredients consisted of nutmeg essential oil, dimethyl phoxide as solvent, and several stock cultures of bacteria, E. coli, P. aeruginosa, S. aureus, and Propionibacterium acnes. The separation process involves heating the oil in a boiling flask under reduced pressure, which protects heat-sensitive compounds and allows for the effective fractionation of the oil. Once we obtain the fractions, we examine their antibacterial activity using the agar-well diffusion method. For the assessment, we cultured the bacteria in nutrient broth, prepared the agar medium, and created wells for introducing the nutmeg oil fractions. Each well received a specific volume of the samples, and the plates were incubated at 37 degrees Celsius for 24 hours. We measured the inhibition zones using a vernier caliper to quantify the antibacterial activity of each fraction, along with controls for comparisons. And the fractionation process yielded 5 distinct fractions. The GCMS analysis identified the composition of each fraction. For example, in fraction 5, Myristicin was notably enriched to 53.56% compared to 20.26% in the original nutmeg essential oil. And the table 2 summarizes the antibacterial test results. The results highlighted that only fraction 5 exhibited antibacterial activity at a concentration of 1000 ppm, contrary to the crude oil and the first 4 fractions, which show no inhibitory action. We observed the large inhibition zone diameter from fraction 5 against S. aureus, measuring 3.30 millimeter. Other bacteria like E. coli and P. aeruginosa saw lesser response, and all other fractions had no inhibition zones. For amphenicol, our positive control has demonstrated significant antibacterial activity, reaffirming our methodology effectiveness. In conclusion, our research successfully enhanced the antibacterial efficacy of nutmeg essential oil through vacuum fractional distillation, isolating its active components effectively. The concentration of myristicin in fraction 5 was crucial for its antibacterial potency, particularly against S. aureus. Thank you for your attention, and I welcome any question or discussions on our works.
Okay, thank you, Ms. Bara, for your presentation. Here we have one question in chat room from, I don't know, from Ms. Reza. Ms. Bara, from your results, does the essential oil work more effectively against gram-positive or gram-negative bacteria? And what factors contribute to that difference?
Okay.
You can answer.
Can I answer in Indonesia?
Yeah, okay. It's okay.
Ya, perbandingan ini ya, Miss, antara gram positif dan gram negatif dari essential oil ya, Miss Reza ya. Ya, jadi ini masing-masing mikroorganisme itu memiliki kondisi optimum untuk mereka tumbuh masing-masing. Jadi untuk positif ini, E. coli dan P. aerogenesa ini kurang lebih memiliki E. coli, P. aerogenesa dan S. aureus itu memiliki zona hambat atau inhibition zone-nya itu tidak terlalu signifikan karena mereka mempunyai kondisi optimum untuk tumbuh yang kurang lebih sama, sedangkan P. acne ini dia berbeda seperti itu. Walaupun mereka sama-sama untuk S. aureus dan P. acne itu dia itu gram positif seperti itu ya.
Does that answer your question, Ms. Reza?
Oke, berarti memang belum terlihat perbedaan yang terlalu signifikan ya antara gram positif dan gram negatifnya begitu ya?
Ya, research ini lebih ke optimalisasi ini sih, optimalisasi senyawa antibakteri dari minyak keciri biji palanya. Kalau untuk antar bakterinya belum sejauh itu.
Oke,
mungkin bisa dari MIC value.
Thank you, Ms. Bara.
Okay, thank you, Ms. Bara and Ms. Reza, for your answer and question. Okay, maybe we can move to the next presentation. Next is from Professor Muhaimin Rifai, PhD, and will be present by
Muhammad Fitri Atauillah. Maybe I will introduce myself later.
Okay. The time is yours, and I will remind you that it's only 10 minutes for presentation and answer the question. The time is yours.
Okay,
you can present your presentation.
Is it my screen is clear?
Yeah, we can see your presentation.
Okay, wait. Okay, good afternoon, everyone. I will represent my lecturer, the Professor Muhammad Rifai, because he is suddenly on another duty, so I will substitute him to presentation. So, my name is Muhammad Fitri Atauillah, and I will present about our research about comparison between fermented and unfermented bulk curcuma based on the antioxidant assay and the phytochemical content. So, Indonesia have a mega biodiversity like we know, and maybe curcuma, most of us is familiar with kunyit or curcuma domestica like that. But in another curcuma, is endemic curcuma, for example, is curcuma hineana or temu giring, and curcuma aromatica, which is called in Indonesian temu putih, is several type or example for the endemic curcuma that can be found in Indonesia. And this curcuma traditionally valued for their anti-inflammatory, antimicrobial, and antioxidant properties. And what is our research do? We do the fermentation. So the fermentation is we know that old technique using bacteria to improve the metabolic content and its functional properties. So in here we use lactic acid bacteria or BAL or maybe probiotic. We use Lactobacillus plantarum to ferment the Curcuma hyacinana or temu giring and Curcuma aromatica. So we try to biotransform the metabolite, the secondary metabolite, to enhance their functional properties. The aims of this study, first is to determine the total phenol and total flavonoid content in 2 species of wild curcuma. Second, to determine the antioxidant properties in 2 species of wild curcuma. And the last, to compare between the fermented and unfermented extract of curcuma. So for the method, first we use extraction using absolute ethanol as a solvent, then we evaporate it using rotary evaporator, then we do the fermentation with 1% of curcuma extract, was fermented with 10% of probiotic Lactobacillus paracasei for 48 hours, then we freeze dried. And the result of the freeze dried, we check the phytochemical content, including total phenol and total flavonoid. Then we check the antioxidant properties using DPPH and ABTS antioxidant activity assay. Then we evaluated the fermentation and the unfermented from its bioactive compound. For the result, we can see in total flavonoid content for Curcuma hyacinana and Curcuma aromatica have higher flavonoid than the fermented sample. And this is in line with the total phenolic content, but in the antioxidant activity assay in IBTS, the fermented curcuma hyacinana and fermented Curcuma aromatica demonstrated closely IC50 value. With the TPPH also have the similar result. What is interesting in this study, because 1% gram of extract could have the close value with the unfermented samples. So the fermentation could increase the secondary metabolite and its functional properties of curcuma. So as I said before, the 100-fold of dilution from the extract during the fermentation increased the phytochemical content about maybe around 10 times. The biotransformation by LAB increased the bioactive compound in the extract. What caused in here? Because the enzymatic action of lactic acid bacteria such as beta-glucosidase and esterase can break down the complex phenolic and flavonoid glycoside into more bioavailable glycon form. So they could break down the complex metabolite to the simpler one, and the simpler one have more functional properties. And the fermentation also supports the development of beneficial metabolites such as short-chain fatty acid and bioactive peptide. This mice nearby with curcuminoid and the volatile oil. And the conclusion is fermentation by LAB in curcuma has better result on the phytochemical and antioxidant assay. However, the further methods of fermentation and study in vitro and in vivo is recommended to perform to provide the complete data about the efficacy of the fermented curcuma. Thank you. For the acknowledgement, I will thank you for Brawijaya University for funding this research through the scheme of Ecosystem Research Kerjasama International with University of Malaya. Thank you. I will turn it back to the moderator.
Okay, thank you for your presentation. Maybe there's question from presenters. Then is okay. Maybe I just want to ask you one question. From your presentation, which phytochemical compounds show significant changes after the fermentation process?
Okay, thank you for the question. maybe it's difficult to answer because the answer may need metabolomic data from maybe from LC-HCRS result or maybe through HPLC, but in the curcuma wild species from Curcuma hiniana and Curcuma aromatica, they also contain curcuminoid, but maybe not significant, not higher as the Curcuma domestica or kunyit. Maybe the change is maybe from the curcuminoids, I think.
Okay, because it is the unique compound from your samples, right?
Yes.
Okay, and it's need for more exploration using HPLC or LCMS, right?
Yes.
Right. Okay, thank you, Mr.
Muhammad Fitri.
Oh yeah. Okay, thank you for your presentation. Maybe we can move to the next presenter. It is the last presenter. It is Miss Tuba from Turkey. Miss Tuba, can you hear my voice?
Yes, but I am soon going to meet my lecture, so could you please show my
Perform your video, right?
Yes, and
okay.
I can try to answer your questions.
Okay, thank you, Mr. Maybe because there is a problem and there, we want to show you your video presentation, right? Okay. Okay.
Now?
It's okay. We have your video.
Okay, thank you.
Okay, we will show it. Okay. We sincerely apologize because that Miss Prof Tuba there is only able to submit a recorded video presentation due to limited network and connectivity. We will give the presentation from the video. Okay.
So as in this presentation, I will discuss the evaluation of the chemical quality and antioxidant potential of products by dividing it as dietary supplements. This project was supported by two Italian university students research projects support from products are widely marketed to limited regulatory oversight, raising concern regarding their safety, quality, and authenticity. Many are promoted with exaggerated claims these packaging standardized production of pharmaceutical validation. Given this issue, determines the amount of extended capacity of the awarded preparation becomes essential. This study addresses this concern by evaluating the family fine and antioxidant quality when you need products sold in early shop and market. When you work there,
who did 16 randomized control trials, 2 cohorts studies, and 5 ongoing trials. Also, several other relevant clinical investigations. The include studies represent the diverse geographic regions, such as Asia, Europe, the Middle East, and the Americas. Sample size range from 10 to more than 2,500 participants, with intervention duration typically 8 and 12 weeks. Studies assess health-related quality of life using validated tools and must also evaluate fatigue, dyspnea, cognitive symptom, or inflammatory markers such as CRP. And category of intervention that we classified into 4 major, such as herbal formulation, nutraceuticals and vitamins, probiotic and systemic enzyme therapy, and combination or multimodal approach. These categories highlight the broad range of natural products currently explored for PCC. For herbal formulation, it shows promising improvement such as Bojum Dikji Tang, Kyunggokgo, and Chongwon Boshim Dan improve fatigue and dyspnea. Shengjin Yushi granules reduce breathlessness, while Jingxi herbal tea supported symptom relief and immune regulation. This finding suggests that herbal medicine may target inflammation, energy metabolism, and respiratory symptoms common in PCC. Nutraceuticals also showed substantial benefit, such as picogenol and Centella asiatica improve heart-related quality of life scores and reduce inflammatory markers. Vitamin K2 and D3 improve physical functioning and SF36 scores. Omega-3 supplementation was associated with reduction in fatigue and cognitive fog, supporting their neuroprotective and anti-inflammatory roles. Probiotic improve gastrointestinal function and immune balance, while such as adaptogen, radiola, and ashwagandha enhance energy level and cognitive clarity. Enzyme probiotic blends produce rapid reduction in fatigue, highlighting the relevance of gut immune pathway with PCC. And combination therapy showed synergistic effect. Nutraceutical combined with rehabilitation improve dyspnea and fatigue. Pielute or paramitoyl ethanolamide and luteolin paired with olfactory training enhance spell recovery. An essential oil contains rose, eucalyptus, clove, lemon, citronella, mint, vanilla, and cedarwood, contributing to reductions in fatigue and emotional symptoms. Across studies, natural products consistently demonstrated potential to improve quality of life and reduce persistent symptoms. Their mechanisms, such as anti-inflammatory, immunomodulatory, antioxidant, and neuroprotective, align well with the multi-system nature of PCC. However, evidence quality varies. Many studies have small sample size, short duration, and inconsistent outcome measures, limiting the strength of conclusion. So, in conclusion, natural product interventions show meaningful potential to support recovery in adults with PCC. They are generally safe, accessible, and may improve multiple health-related quality of life domains. Nevertheless, high-quality randomized control trial and standardized outcome assessment are still required. This finding support the integration of natural product into PCC management, especially in setting where access to advanced therapy is limited. They may also complement existing rehabilitation strategies and help meet global demand of sustainable, affordable long COVID therapy. This research was conducted together with my colleague Septi Wulandari, Yona Haryanti Putri, and Fauzia Nuprima Orta from Universitas Bengkulu. Thank you for your attention. If you have any question, please feel free to ask me now or contact me in the email provided. Thank you for your attention.
Thank you, Ms. Rizky, for your excellent presentation. Yeah. Is there any question? Okay, no, yeah. Okay, thank you once again for the thoughtful presentations, both from on-site and online participants. As we conclude topic 2, natural product-based medicines, I would like to express my sincere appreciation to all presenters for sharing your valuable work. Your contribution highlight the growth
Recording in progress. Recording stopped.
you.